few community is there. So one community, if you join in the community as a community member, so in yearly you need to pay 1199 rupees, and you will get many benefits. So I'm going to tell you about the benefits one by one. First benefits, you will get free consultation with Dr. Rathore, and you will get free webinar during the 1 year anytime when it will happen. So yes, few of them also you receive some certification from my end, I believe. So you will get that the certificate you will get, and you will get a workshop within a year. And yes, and I will be requesting you to refer more if you want to refer your colleagues, your friends to join with us so that we can grow more. And also we are going to this time, this is the fourth seminar, on BESS. Next time we will be going forward, we'll be arranging more seminar on other renewable energy part. So please keep in touch with us. And currently we are going to launch one more program in this 26th of Jan. Okay, so here we are going to train few whosoever registered with us, whosoever will be registering with us as a member. So we will going to give the free training for them for the job. So we already connected with few companies who are or seeking for the candidates. So we are connecting with them, so we can place them according to their criteria. And also, one more thing for any company, any marketing representative, if you want to come with us, so you can also represent your product demo. You can showcase your product. You will be given 5 minutes with us, and you can tell about this. So here we have many people who are connected. Almost in between these days, we have connected with 2,000 almost people. So we are all with them. So yes, from this is so you need to pay for this 2100 for the company marketing representative. So you can connect with me anytime in this number. So I am in the group. You know me. So I think this is the. I mean, I want to. From my end, I have completed. So Dr. Rathore, please, you if you can take the thing, the discussion as of now.
Okay, thank you, Priyasri. It's 6:03 only. I think someone is still joining. So whatever you have said, uh, कुछ लोगों ने शायद नहीं सुना. I just briefing. Okay. Uh, Actually, what we are doing, one thing is that we have made a WhatsApp community. Okay, that will be converted to a web-based community in coming time, and all will get who will take the membership. Basically membership is we started from 3 rupees 365, 1 rupee per day only. But what we have seen that only around 40 people is only joined that one. So we now the we have kept that fees around 1199 rupees. Okay, who are becoming the membership. Every renewable energy on daily basis update. Right now, I am updating at our means this free RE community, but I will especially means technical discussion also can be done on this community right now in WhatsApp, but further it will come to web-based community where you can see the post from different other members also, and there will be clear-cut membership registration ID will be there. Okay, and what is the benefit in that? You will get all webinars for 1 year free. All webinar recording will be posted there in the web-based webinar. Right now, I am sharing through YouTube, but further, no YouTube that will be put there. Okay, like that. So We have also done what if you refer someone, we have kept 35% affiliate marketing time. Means if you refer two-person, so you can get 70%, 35% for each. So your fees can be recovered if you refer anyone. Okay, this is also option. And recently we started new thing. Means anyone want to tell about their product or services, because right now few members are there in webinar, but when we will start with this ad, Google and Meta ad, we are expecting around 300 to 500 participants. Then your approach to your product and services will be high. There are high chances. So at that time it will be better to come and showcase your product or services, and you can get approach, okay, accordingly. Later you can see that one. And by 26th January, what we are doing, we are getting collecting the database of the needy people who are interested in joining through us, where we will give free training to them. Once they will show the interest, then we will give them training, and we will other corporates or companies who are in our touch, we will send them there. We are not taking any money or anything else from that one. Free training we are providing. Either is join or not join, it is not needed, but we will give free training, that is sure. Okay, once, but database, there should be a registration. Means your name, email ID, phone number, your experience, your core area, all these things, means CV required basically. You can contact to privacy. Okay, now let us, it's 18:06. We just start today's session. So, my is this, it is visible slide?
Yes, your slide is visible.
Yes, visible.
Okay. Good evening, everybody. And today is our fourth webinar on this battery energy storage system. We all know that now in India, especially, battery energy storage system is coming fast. We can see, okay, because everywhere, either it is smaller level or our at a commercial level, we had to go with this one. Means, yes, Mr. Parth Sarthi, can you tell me what you want to say?
No, no, sir. You just asked, no, that is it visible or not? That's why I raised the hand,
Okay,
sir.
okay, okay,
Yeah,
okay.
I'm good, sir.
So, what are our planning? We want to make this session very interactive. Means, okay, you right now note down whatever the questions. But yes, if you are not getting, really you are not getting, you can raise your hand, and definitely we will answer meanwhile. Okay, but we will try that we shout out that one in shorter period. Otherwise, what will happen, all other will be disturbed. Okay, but in later on in question answer session, we will discuss in detail. All others can also discuss with each other. And earlier in last webinar also there were 2 3 points which this time I have discussed on that. We will discuss on that because some problem were there. Okay, some understanding gap. Actually, some slide were one slide came before. Basically, this was the only issue. Okay, let's start. So, battery energy storage system, we have all know about that. It is a part of storage system. Means there are different type of storage system. One is battery energy storage system. Means battery we are using as a chemical. The energy is stored is stored chemically. Other one is the pump hydro storage, where through pumping the water at elevation, we use that water storage again at a same hydro power plant type, and the pump which are used, that is use the renewable energy only. Source is renewable, solar or wind, whatever. Okay, so that is also it is also used when there is no power demand is there, means, okay, at that time we can use that pump hydro storage. It is mainly installed near where the water is there, means near the seashore, or especially for hydrogen plant it is coming. Okay, it is that just only in process, but not so much installed in India, but yes, it will also come. Right now they are more than BESS. Okay, And third one is the thermal storage, where thermally through heat energy is stored. That will be basically used in CSP, concentrated solar power plant, means that is also called solar thermal power plant. But in India right now there is no thermal storage as on date installed in India. But yes, it will also come in coming time. I think NTPC is floated a tender of 50 megawatt with thermal storage, whatever type of means CSP plant, but still it is not in line. Okay. Fourth one is the fuel cell. Fuel cell means through hydrogen. Through hydrogen, this energy is stored in the fuel cell, then it is again converted. Right now, it is already started in Jammu Kashmir by the Tata. NTPC, I think, providing the these buses, EV buses, where this hydrogen buses already started there. Okay, about me, you all know. So I am not repeating this one. I am a PSCC Power Sector Skill Council, which is promoted by Ministry of Power, Ministry of New and Renewable Energy, Central Electricity Authority, and EMA, and National Skill Development Corporation. That is a agency which provide training and certify them. Okay. In coming time, CA regulation is coming in enforcement where every company, every corporate has to provide skill training to every employee, and they have to get certified. It is becoming very soon mandatory. Okay. Right now, I am the India first certified master trainer for renewable energy because they were in the transmission, distribution, and generation, but they were not available at that time. But first time I given the training for them. Okay, and next is also I'm going to deliver very soon. I have worked in textile, coal thermal, solar PV, wind. Okay, all these projects I have done. Mainly, I have done projects in O&M also for some years. I have worked in Maharashtra, Andhra Pradesh, Tamil Nadu, Maharashtra, Rajasthan, MP, Gujarat. Okay, and personally, I do the for work for road safety. I just want to inform you that our center RDTC. Singawal, which is my village basically, Ajmer district, Rajasthan. It is has been the India first accreditation, international accreditation means every driver who want to go in Saudi Arab, they has to pass our testing at our center only. Okay, first time in India, the India first regional driving training center where the drivers who want to go in Saudi Arabia, they have to take the testing at our center only, as on date. Okay, so that is different thing. We are also providing training with TV Renault. We have done the MOU with them and providing training for green hydrogen and solar. Still, it is not started, but yes, it will also start. Okay. So battery energy storage, what we are going to learn. Okay. Same BESS, rated energy, why it is required, challenges in India. There are a lot of challenges because costing is high, battery cost is high right now. There is no manufacturing in India as on date. Okay, so that is the issue, and because, due to cost, high cost, again the investment is not done by the Indians itself. Technology also something R&D is also going on. What type of battery chemistry we use? Okay, that is and some policy gap is also there. As on date, there is no policy. Just came like green hydrogen. Just we are talking from last 2 3 years, but nothing yet happened at ground. Not a commercial plant is commissioned for green hydrogen. Same in this BSS case. ESO energy storage obligation. We will discuss about that one also in short. Basic battery parameters, various battery chemistry. Today we will discuss about flow battery. There are three batteries mainly. In means the mature is lead acid is obsolete. Okay, forget that. Lithium ion with LFP battery means lithium ion iron phosphate chemistry is that. That is right now again matured, but it's very cheap. Now, sodium ion. Another we are under R&D, that is a sodium. Sodium ion is used abundant quantity available. It's research is going on sodium ion. Okay. And another one is a flow battery. If we want to go in more storage time, so flow battery is easy because it is the chemically it is stored in the liquid form basically. For commercial big projects, it is feasible flow batteries. Okay, tendering we will discuss what are the major things in that RFS document and BESS tenders, penalties, incentives, BSS players, Indian regulations, BIS standards, safety guidelines for basically and quality also. Sample BESS. Today we will focus on BESS cost and payback. Okay, that is important. There are two scenarios basically. Then finally we will question answer and quiz. We will do there. 10 questions are there. This time you have to attend that, and we will give the answer. This is the just specification I want to tell you. This is the LFP. Okay, lithium ion battery, LFP battery, which is normally called LFP battery. Okay, this is the formula. You can say battery chemistry is the lithium LFP, lithium iron phosphate, PO4, LiFe PO4. Nominal output power 105 kilowatt. Battery capacity 232.96 kWh means average 2 hours storage is there. Battery nominal voltage 832 volt. Operating DC voltage range 650 volt to 949 volt. Three phase four wire, and output is the 400 volt AC. Okay, in form of AC basically, and DC 650 to 949. Recommended charging discharging current 140. Firefighting system is also shown. Cycle life is 6,000. DOD depth of discharge 90%. Warranty and without disturbance of this efficiency, we can discharge up to 90%. Warranty 3 years. Communication port is also available. RS485 Ethernet communication protocol Modbus TCP and RTU. This is the dimension, weight, cooling system, liquid cooling. Okay, here is the liquid cooling. HVAC also is there. Another type of cooling is the liquid cooling. IP protection, IP54. And humidity and temperature range is also shown minus 55 degree, ambient 20 to 55 degrees centigrade. It can work. Na? Altitude up to 2000 meters. This is just a specification of a, you can say one in all means all you can say battery power conversion system, liquid cooling, heating, energy management system, firefighting, all in one. X is the China based company basically. This is the product of them. Okay, because around 230 this is no this is same how it is on. We can connect it with the grid, with the rooftop solar. If we talk about a residential purpose, diesel generator also. If there is a colony, for example, DGs also, we can integrate with that. Charge and discharge this one, and where we can use bank, factory, school, hospital, government. For 24 hours power supply, we have to go with this lithium ion battery or sodium ion in which is under R&D. This is how the for commercial purpose how the this is supplied. Okay, this is the container. This is the container basically. In container, all items are inside. Battery rack, EMS, battery management system. You will see the next slide. Okay, how it is packed and transported. That I'm just trying to show you. This is again you see what in this compartment which we have seen this one container. What is this one, these are the cell. Every cell are connected and this is a battery pack. This is called battery pack. Through cell more cells becomes a battery pack. Okay, this is the rack. These are the racks. A gas detection. Okay, because in charging discharging some gas is also developed, so that is also showing. Firefighting system, fire suppression system is there in case of any fire. HVAC cooling system is shown like that. This is the battery management system. This here battery management system is shown. Okay, these are the cell. This is the battery management system. Sub control box it is shown. PLC main control box. Okay, this is the PCS basically. PCS is shown here. Okay, PCS means this one. PCS means power conversion system, which convert grid AC power to DC bidirectional and battery DC to AC as and when required based on the demand of the grid. This is electrical diagram basically how it is connected. This is the battery management system which is connected with the battery, and these all are the battery. You can see, okay, breaker is there, and this is a common breaker. Main DC is surge protection device. DC side, this is the inverter. You can see this is the part of, this is DC part, this is the AC part. PCS, inverter, converter, whatever you can say. In this way, this is the AC grid side. Okay, this is the grid side. How it converts AC to DC? That is the converter. And how this DC to convert to the AC rectifier. This is overall part called PCS, and it is connected to, if we
Sir,
want to
please.
go, yeah.
Sir, AC to DC rectifier, DC to AC is a inverter. It means convert that
DC
one.
to AC is inverter.
Yes, please.
Thank you, yeah, for correcting me. So what others doing? They are listening only. You are getting or not? It is it is very necessary. Hello,
Yes,
if
sir.
you
We are
are,
listening.
Yes,
uh,
getting it, getting it.
I mean, getting it, but only one person raised the that it is wrong. Hmm? That I want to see, na. You are here, you are listening. In chat box, say yes if you are getting everything, whatever I am telling you are getting. In chat box, say yes. I want to see. Total 19 people are there. I want to see you are at your system, with your system. Kumar Rajiv say yes. Dinesh Dan, yes. Parth Sarthi, yes. Good. Harsh Lakwani, yes. Thank you. Thank you. Okay, thank you. Great, great. Okay, means everyone is getting and they are with their system. Okay, next. So now it is clear what inverter do. Inverter convert DC to AC. Okay, this is okay, na? Yeah, various component of BESS. Already we have seen this one. Okay, now we have discussed the electrical diagram. Now we just see the various component of BESS, battery energy storage system. It is a type of storage where power is stored in chemically. Okay, that is in the battery. Battery is in chemical. Battery modules and cells, the core of BESS. 70% costing is only battery. Okay, around 70% costing is only battery, where energy is stored chemically. Battery management system. It monitors and manages the state of charge. Means what, at what stage the battery is charged. State of charge 50%, 60%, 70%. Accordingly, it gives the signal to EMS, energy management system, which decide which charging is required or not required, whatever. Okay, it should be known by the EMS. Then only it can act. And state of the health, temperature, ensure safe operation. Okay, all cell, individual cell is also monitored for their degradation, their temperature, all these things. Power conversion system converts DC energy from batteries to AC for grid compatibility and vice versa. Convert DC to AC and AC to DC. This is a common word name, PCS, power conversion system. Both function DC to AC or AC to DC, bidirectional, like that. Okay, inverter is also there, and rectifier is also there. Thermal management system maintains optimal thermal management is necessary, because during charging, if there is normally we have considered one charging discharging cycle, okay, as per in the BESS tender. But if there are much more charging discharging, then thermal heating may be there. Okay, so thermal management is necessary. And another is the energy management system. Optimize charging and discharging. This is optimized. When charging required, when discharging required, that is optimized through the energy management system based on the demand, supply, and grid. Because all this battery energy storage system is like a generator also and distributor also. Just I said earlier also. And voltage are high, grid side voltage are high, or there is power demand is low, then this this battery will be charged. When there is demand, there is a demand in grid, or voltage is lower or frequency lower, so it works as a ancillary device, means it maintains that one. Okay, it maintains the grid voltage, grid stability by providing power from the stored power to the grid. That is a main function of BESS basically. Safety system, fire suppression system already we have. Ventilation is also necessary, and protective enclosure, which we have the rake, that enclosure. Energy storage like solar RPO, wind RPO, which is around 25% right now. Energy storage obligation or ESO is also there. Okay, it is mandated in July 2022, but much more not aware by the people. But it is applicable only when your captive consumption for your factory, or maybe your any thermal power plant is there, or you are consuming whatever the captive consumption is there, it is higher than 85% renewable, only renewable. Then only this is applicable for you. So what is right now in 2024-25 financial year, it is 1.5%. Right now it is 1.5%. After March 2025, it will be 2%. It will increase by 0.5%, and every year it will increase 0.5%, and finally by 2029-30 it will become 4%. Okay, it will become 4%. Another thing is that right now it is not mandated, but now it is coming soon, that in the India, without any policy or without any regulatory, nothing is installed. So now it is coming, 10% of your solar and wind capacity has to be ESS only, energy storage system, either thermal storage or pumped hydro storage, whatever. Okay, and you can install this one. If for example 100 megawatt is there, 50 megawatt you are installing at one place, another state or another place, 10% ESS can be there, but minimum solar is required. You cannot only stand alone like that. It is coming very soon, and it will go up to 40% in, I think, 2028, when our battery prices will be very lower, and cost of this BSS system will be low. Mainly it will go BSS only. Okay. In this graph, you can see right now what is the condition. By 2027, the scenario is that the PSP, pump storage plant, gigawatt hour, 47.6 point will be there at that time. But BSS will be less, 34.72 million. Still by in 2025, it will ramp up, but we cannot go up to that level. But after that, you can, the 2031-32, it will become 236.22 gigawatt hour, which is our requirement, 45 gigawatt something, and 236 with around 6 hours. Okay, 6 hours storage, 236.22. It will go, and PSP will be 175. You can see PSP also grow fast. Here you can see 540 PSP, then battery storage will be 1840, BSS will be 1840 gigawatt hour by 2047. So you can simply see that how BSS will be grow in coming time. This is just a requirement I have shown. Different scenario, best case, conservative, high demand. We just discuss high demand scenario because demand will grow. You cannot predict right now what demand will grow, but it will grow very fast. So we can say 49.3 gigawatt to 46.9 gigawatt hour requirement will be there for BESS, battery energy storage system. Basic terminology in a battery. Okay. Round trip efficiency. What is this one? Anyone who have joined earlier in
Cycle means charging and discharging.
correct, very good. Uh, means any battery when charged and then again discharge, complete cycle, round trip. Okay, what is the efficiency? Means how much kWh it is consumed during charging, or what kWh it is delivered. So it is a ratio basically. Okay, it is a ratio means we can see the efficiency when whatever the losses are there. Okay, that is
Yes, sir.
it comes around 85% or 90% like that. We'll see later. Depth of discharge. Anyone can tell depth of discharge?
How the battery is discharged
95%.
means 80%, 90%, 95%.
Up to 95%, 90 to
Honey,
95%.
what is the definition of depth of discharge?
Depth of discharge means the maximum वो जैसे आउटपुट ले सकता है वो बैटरी फॉर एग्जांपल 1 किलोवाट मींस 0.9 किलोवाट तक आप ले सकता है.
Up to what percentage we can discharge the battery so that
Correct,
its life
correct,
will not
correct,
impact.
correct. Very good. So means without impacting of its efficiency or performance, at what level, up to what level we can discharge the battery. That is the depth of discharge. Means if LF, we talk about LFE battery, the depth of discharge is, for example, 90%. Means up to 90% if you are discharging, okay, then still this it's whatever this round trip efficiency we can say, or its efficiency or performance life cycle, that will not reduce. Otherwise, you will discharge 90. For example, OEM given 85%, but you are discharging it to up to 95%, yeah, 90%. Above that, whatever given by the OEM, it means the life, the guarantee also, the warranty is basically for 10 years. That will also impact. We cannot go above that one. Energy density and power density. There are two words. Energy density is that at watt hour per liter, whatever the electrolyte per liter or per kg, how much watt hour it can a battery can store. That is the energy density. It is a measure parameter. In the sodium ion battery, the energy density is very less compared to the lithium ion battery. So R&D is going on how we change this cathode or material so that we can increase this energy density. Okay? How much it can store, and power density is deliver how much watt hour per kg or per liter, whatever volumetric or gravimetric it can deliver again. Okay, these are the two terminology. State of charge, at what state battery is charged means battery charge is 50% or it is charged is 65%. It is just a measurement basically, which is measured by the battery management system. And accordingly, the signal is goes to energy management system, who decide कि it battery should to be charged on what to be discharged. Okay, and grid parameters, forecasting of demand, also it is seen by the EMS. Accordingly, it is decided. All are in a synchronized way. It is worked. Self discharge rate means idling. There is no means you have charged, but there is no discharge. Means there is no demand. This may be a condition. Okay. In that case, there is idling. What is the self? It is very less, 1% around. Okay. Temperature, operating temperature range, ambient temperature range where it can work. C rate, charge and discharges. The any battery like 0.5 C, 1 C. What is this one? Who will tell the C rate? What is C rate? It is very good question. C rate in lead acid battery also C rate is comes. So who can tell me what is the this C rate? Anyone?
Sir,
C
I
rate is
don't know
the
the. Yes, yes.
One person.
Yes, continue, please.
Yes, Hemraji, बोलिए.
C rate is the maximum charging and discharging rate, sir.
No, it is not so.
Okay.
Means actually C rate means like if a battery rating is 100 ampere hour, for example, okay, or I am giving it 1 C, for example. 1 C means if I give 100 ampere for 1 hour, okay, it will be charged. Understood? Means either 100 ampere load is there for 1 hour, it will discharge. If I say 0.5 C, like for LFP battery, if I say 0.5 C, in last webinar also, no, the Jesse is telling कि our LFP battery is 0.5 C C rate. What does mean 0.5 C? Means if we for 50 ampere for 2 hours, okay, 50 ampere for 2 hours, we have to give it, then it will charge and discharge also 50 ampere in 2 hours, like that. Charging and discharge rate, both charge and discharge rate means C rate. 0.5 C means fast charging is not there. Matlab means if you will give, for example, 0.5 C is the C rate is given for battery. It means uh, for if you talk about 100 ampere hour for 0.5 C means if I will give 50 ampere for 2 hours, okay, 50 ampere for 2 hours, then battery will be fully charged. But if I will give 100 ampere for 1 hour, what I am doing, whatever the C rate is given, I am not following that one. Means the fast charging and fast discharging we are doing. Ultimately, whatever the rating is given, we are going against that one. Okay. So it depends on the battery life is also depend on the C rate, what how we are charging and decide what rate. Its full capacity to it is seen from its full capacity. Okay, what I am just given the example of 100 ampere hour battery. That is 2C. If I give 2C means if 2C is given means if you will give 200 ampere for half an hour, it will charge like that. Cycle life, how many cycles we can charge? 1,000 to like 10,000 cycles. In flow battery, the life cycle is the cycle life is very high. In flow battery, about 10,000. Lithium ion is in the range of 1,000 to 10,000. Battery, different battery chemistry is there. Sodium ion, lithium ion. Okay, these are the basically used in energy storage system. Right now, lithium ion is going on, but it is also maturing and all R&D is going on because it is very costly and lithium is not available abundantly. So and sodium is available in samudra sea. We can just demineralize it and take the sodium. So sodium ion R&D is going on. Comparison of lithium ion, LFP, sodium ion, and flow batteries. These three basically batteries are there. Either they are under R&D or like flow batteries, energy density is less. LFP, these are the cheap and best battery right now, as on that, lithium ion, LFP. LFP battery best suited for high energy and power density applications such as electric vehicles and portable electronics. Sodium ion, emerging technology with moderate energy density. Moderate energy density we need to increase. Ideal for stationary energy storage due to its cost effectiveness and abundant raw materials. Flow battery excellent for large scale energy storage system, grid storage due to their long life, 6 to 7 hours backup storage is there. Lithium ion, either we are going with 2 hours, either 4 hours. In last webinar also I have shown 1000 megawatt oblique 4000 MWH. What is in 4 hours energy storage there? Or you can say 50 megawatt oblique 100 MWH means 2 hours energy storage there. But if we are using flow batteries, we can go up to 6 hours, 7 hours, 8 hours storage. In electrolyte remain in the this one liquid form and it is stored in the tank. Okay. Now, this is the round trip efficiency. Lithium ion 90 to 95%, sodium ion 85 to 90%, and flow battery 65 to 85%. You can see efficiency also comparison. Depth of discharge, LFP battery 95 to 100%, even up to 100% we can discharge LFP battery. In PITES battery, whatever the Jesse also told, we can our battery is 100%. Up to means 95 to 100% we can offer. Sodium ion 90 to 95%. Flow battery is also 90 to 100%. Energy density, watt hour per liter or watt hour per kg. That is the energy density. At what, how much watt hour it can to store the energy basically. है ना? So what is that one? How fast it can store the energy basically. So 200 to 260 watt hour per kg for LFP or 300 to 400. Two ranges is one. Sodium ion 200 to 260 watt hour per kg only we consider here. And sodium ion is very less. See here 100 to 150 watt hour per kg. Flow battery very less. What I am saying, the energy density is very less in flow battery. It's only 20 to 40 watt hour per kg, which is very less. But backup time is very high. Storage is very more hours we can store. Lower maintenance. Power density LFP battery 300 to 1000 watt per kg. Power density means at watt per kg at how it can deliver the power. Basically, that is the power density. This is 200 to and sodium ion is 200 to 500 watt per kg, and this is again very less flow rate. Straight up charge 5 to 100% we can charge 5 to 95%. Here you see 5 is minimum, okay, 5 to 95 sodium ion, and LF is 100%. This is again good in this case, SOC, in case of SOC. Flexible 0 to 100% flow battery. Self discharge rate idling 1 to 2%, 1 to 3% per month basically. Negligible flow battery, there is no discharge. Self discharge. Temperature obtaining minus 20 to 60, minus 30 to 60, 0 to 40. Here you can see flow battery 0 to 40. In minus, the liquid form will be freezed, become solid. So it is not possible. That we need to understand this one. Next is a C rate 1 to 3C. Can you see? 1 means 100 ampere hour battery is there. Means if we give 100 ampere for 1 hour, it will be charged and discharged. Up to 3C, fast charging, discharging. But in case of sodium ion, 1 to 2C. But in case of flow battery, we cannot fast charge, we cannot fast discharge, 0.1 to 1C only. That also we need to understand. Cycle life, LFP battery 2000 to 4000 cycles, sodium ion 2000 to 3000, and the flow battery is best in the cycles. Earlier I told 10,000 to 20,000 cycles, no impact. Battery chemistry, lithium iron phosphate. This is the chemistry, LFP, lithium iron phosphate, which is short, in short term, it is called LFP, lithium iron phosphate. This is a chemical formula. Sodium based, sodium ion chemistry, and here redox flow chemistry, vanadium. Vanadium is the cathode, basically, cathode metal.
Now, mostly using battery energy systems, the flow batteries.
No, sir, lithium ion, LFP.
Okay, if lithium ion means the below 4000 cycles, no?
Below 4,000 cycle, but they are right now cheap, and it is also matured. But the R&D is going on sodium ion. Flow battery is also used, but again I'm telling you about multiple storage time 6 to 8 hours, total 8 hours storage is required. Like in USA maybe or commercial projects, very big projects are there. Then it is used basically.
Sir,
Sir, it means the BESS, the life is below 10 years.
No, not years. Cycles means one cycle means I told na
Charging
once
and
it will be
discharging.
charge and discharge. That is
Correct,
called
sir.
one cycle.
For example, 1 day per day, charge and discharge one cycle was completed. It
Correct,
means the
correct,
per
correct.
year
Yes.
365 cycles was completed. It means 365 into
1 year,
10 years.
1 year 365 will complete.
Yes,
So you
sir.
can say
Into
that 10
10,
years is
3000.
alive.
Yeah,
Ah,
3650. Maximum the battery life is 10 years, correct?
correct. 10 years is the battery life. Warranty of battery is also given by the OEM is only 10 years. Okay, if you
Okay.
maintain it properly and SOCI is also maintained and the C rate is also maintained, all these things are maintained.
Uh, Excuse me, sir.
Yes,
Hello.
yes.
Sir, actually, I was reading one of those BESS tender documents, where they are talking about a 12-year PPA.
12
12
year
साल का 12 साल का PPA, because battery का degradation, they are talking about linear efficiency of 2.5% per year. Is it
okay.
okay?
And he
No,
want to 15-year warranty, sir. In
no,
some
no.
tender document, he want to
I
15-year warranty, sir.
1 minute, sir.
average warranty is 10 years.
Okay.
But this Pitus also told that जैसे कि whatever we are providing warranty for 10 years, but
Okay.
it can be extended for 2 years or 3 years, whatever. Initial warranties he was talking. Okay. Normal life is 10 years, normal life 10 years, but it can be extended. It depends on how we are maintaining. It depends on SOC, it depends on C rate, it depends on how many cycles. We are just assuming in the SECI, we are assuming one cycle minimum per day. That will be more also, that may be less also. It depends on that. But yes, 10 to 15 is the life. What I
Okay.
can say. Yeah.
Fine. Thank you, sir. Thank you.
Yeah, yeah. This is the round trip.
Sir,
Yes.
sir, in case the cycle is not also completed in 24 hours, the battery will get discharged after 6 hours. So
No, no,
again, you have to
no.
charge
Why
it.
hours? Why discharge? If there is no load, there, why battery discharge? Idle only 1% may discharge in case of lithium ion battery.
Okay, if it is not discharged, then it can store, it will self discharges only 1 to 2%, right, sir?
Idle. In idle condition,
Okay.
automatically
Okay.
per month. 1% is
Per
also per
month.
month.
Okay,
It
okay.
means very less. It
Got it.
means very
And
less.
sir, can you derive any relation between this energy density and power density? That if the energy
Yes,
density is
why
high,
not? Why not? It depends on the round trip efficiency. Means like energy density, what how it is at what speed means watt per kg. Whatever the is
Mhm.
electrolyte is a kg or liter. What can you say? It how watt hour? Sorry, watt hour per kg.
kg.
How it is storing the energy? Okay, what is the
Yes.
speed per kg or whatever the per kg or per liter electrolyte is there, and how it is delivering.
Delivery.
So it can store more, means you can say
The more
battery
it
can
can
store
store,
more
the more
and
it can deliver,
deliver
right?
less. So that is again the efficiency. It is called efficiency simply.
Mhm. Okay, okay,
Good
okay.
energy, matlab, the energy density is good. If high, it means the battery is good. We can say
Good.
simply.
The power density will also be good.
Power density will be automatically good.
Okay, sir.
Yeah. So these are the parameters we have seen. Okay, temperature, operating range, and battery chemistry. Okay. Yes. What are the various battery chemistry? I just want to say, like sodium ion battery, also R&D, under R&D. Sodium means it found in the sea, samundar, where we have to demineralize the water and collect the sodium. So it's abundant quantity there. So this is the rate, the 70% costing of BESS is the battery basically. Okay, so how this cost can be reduced? So R&D is going in India also and other countries also on this sodium ion basically. Flow batteries also means under R&D. Solid state, another battery is solid state, means the liquid, there will be no liquid electrolyte will be there. Solid state battery, it is also under R&D. What is the difference that need to understand in basically lithium ion, simple, normal or LFP? You understand this difference first. Both are commercial, matured right now. 150 to 250 watt hour per kg energy density of lithium ion normal, but LFE 100 to 150. Okay, but what is increasing in LFE? Cycle life increasing, cost reduced. Okay, cost you can see reduced in INR. I have seen shown the cost here. Efficiency also increase. It is and the temperature is okay. Grid storage and EV it is used. The main thing is that cycle life increased and cost reduced. These are the two factors in LFP battery. Okay. Now NMC, this is again nickel, manganese, and cobalt. Cobalt is very costly. So that is also commercial 150 to 50, 1000, 2000 cycle life, cost high. You can see here efficiency 85 to 95%. Okay. Again, sodium ion. We discuss about sodium ion because this is the next battery. In 2028 means it will come. R&D is going on. Energy density is very less, but how it can be increased, it is I will discuss next slide. 100 to 150 is the energy, which is very less compared to lithium ion. 2000 to 4000 cycle cost okay 85 to 90, mine 10 to 20. Flow batteries R&D very less, energy density is very less, cycle life is very good. Okay, same lead acid, okay, this is obsolete. Solid state batteries is also under R&D. Means we have to go, if anyone asks you, to lithium ion is the matured right now in commercial. It is going on with LFP, but R&D is going on sodium ion, flow batteries, and solid state batteries. Why it is a what is the benefit of solid state? 300 to 500 energy density. Okay, per kg it can store how much watt hour. That is the energy density. Basically, you can understand this way. Cycle life is also more 10,000 plus. Efficiency also 95 plus. Okay, range of temperature is also good. Means this solid state battery is the future. Flow battery unlocking ideas. Okay, this is simple. What are the flow batteries? Already I have told you. Okay, where this you just wrote vanadium redox flow batteries. Okay, vanadium redox flow batteries. This is the chemical reactions one basically. What is that long discharge 4 to 12 hours in flow battery? I told na you discharge in a long discharge 4 to 12 hours. Safe, non-flammable. Safety is very high safety in there because they are outside in tanks. Okay, not in this one rake or whatever container. Vanadium resource, India में you can say Arunachal Pradesh and Odisha, vanadium resources. High upfront cost, lack of incentive, and limited domestic vanadium mining. That to be done. Okay, for flow batteries basically. Sodium ion battery, innovative material, sodium vanadium phosphate. Okay, this one sodium ion battery performance, enhanced energy density in the sodium ion 396 to we can 458 watt hour per kg. That is much higher operating voltage 3.7 volt, stability and efficiency, implications, cost effective sustainable alternative to lithium ion. Lithium ion, if you are searching alternative to lithium ion, which is costly, lithium is not abundant, very scarce lithium. So cost effective and sustainable alternative to lithium ion batteries. Okay. Companies like CATL, which are the major means manufacturer of batteries, aim to mass production by 2027. KPIT, another company, introduced India's first sodium ion battery, reducing EV cost by 25 to 30%. Okay. Electrolyte in lithium ion versus sodium ion batteries, that already we have discussed. You can see in Google also later. Typical safety hierarchy of BESS. If we talk about safety of battery energy storage system, it starts from cell, battery cell. Then it comes to module. All cells connected, it becomes module. Okay. So typical safety hierarchy of BESS. 1 minute. Rajashree, can you mute anyone if you want? I have given you the host control. Hello. Rajashree, are you there?
Yeah, I'm listening to you.
What I am telling, if there is some sound is there, you can mute or someone or not.
Let me check.
Yeah.
No. From here, I am not able to mute anybody.
Okay.
I
No
don't
issue.
have the authority. Yes.
Okay. No issue. So typical safety hierarchy of BSS means Safety is the major thing in the BSS. Okay, which need to understand. It start from the cell, means cell chemistry, cell venting. Okay, during charging, gas is also there. Gas is also generated, so that will be evaporated. Separator materials, cell design, electro engineering, quality control during cell management. All these parameters impact the safety. If we talk about module, means once the cell connected, the slave BMS, battery management system, enclosure design, thermal management, fire management, all these are the modules very much important for the BSS safety. Means these are the basically battery management system for battery. Enclosure is overall cooling and ventilation, everything depend on the enclosure safety. How it thermal management and fire suppression. In case of fire, how we are managing the fire. Rake overall complete master BMS enclosure design, redundant sensing, directional sensor should be redundant. If one fails, another should work. Directional venting, protection such as fuse. Overall system we work to system battery management system, local monitoring and sensor, ventilation, cooling, protection, fire supply. These all things are okay. Then only we can ensure the safety of BSS. Quality issues. This is just for sample. CA cell 30% quality issues. What type issues comes in the cell? Electrode manufacturing during manufacturing of electrode, cell assembly or cell finishing. 30% you can say the quality defects are found during the cell. Then module like cell softening and installation, interconnection welding, enclosing and UL test. These are related to module. System overall we get 48% quality issues. Enclosure, balance system, performance test. This is the Kerala just sample. I'm recently it is I think going on 125 megawatt battery energy standalone. It is standalone battery energy store system. Purpose store what is the in Kerala in daytime there is a surplus energy is there, but they cannot store it. Okay, right now Kerala is surplus energy state as on day, but in night again there is a problem. So what they are doing, store surplus solar energy in daytime for nighttime use. Okay, address peak demand efficiently. So SECI invest tender for Kerala state, KSB to allocate site for the project, prevents financial losses from unused surplus. Means daytime there is energy, but nighttime there is no energy. But in daytime they are not storing that energy. Now through this standalone and means with solar or whatever also going on, they will store this energy. Future plan BESS capacity to expand 3,300 megawatt by the Kerala, basically. The 125 megawatt system delivered 5 lakh units night. Key components of SECI BESS tender. Now we are talking about tender. Any question till now?
Can you go previous slide, please, sir?
1 minute. Yeah. This one?
Sir, last options, future plans.
Acha,
Yes,
this
yes.
one.
Before,
Okay.
yes, expand basis capacity 330 megawatt. Can you explain this, please?
No, no. Simply, they are right now. They stand alone. They just started through SECI bidding
Okay.
going on right now. 125 megawatt. Their target is up to 3,300 megawatt battery energy storage system in the Kerala itself.
So what do you mean by this
Okay.
standalone?
Pardon?
Standalone. What is that?
Standalone means it is not connected with the grid.
So how it will get charged?
Through means through grid or through solar you can even you can buy the power through the grid also, and
Uh-huh.
in remote places and where the power is not available, yeah, in night time requirement is there, so they will go and sell there. They can charge through the grid, they can charge through the solar, they can install their own solar also, or solar and wind hybrid also they can do.
Then no, not getting, sir. Standalone, you are saying that it
Standalone
is
means
not.
one type tender is that where you have to install solar PV plus
Mhm.
battery energy storage system. Okay,
Okay,
for
this one is
example, I am
only
going to
battery energy.
consider
Okay, okay. Got it,
this
sir.
is
Got it.
only standalone. Standalone
Okay.
means only battery energy storage system where, like, for example, in night time, in other places where power is not available, any remote
Hmm.
places, for example,
You
distributed
can
renewable
deliver
energy,
this
you can say.
power.
So there they will supply the power. When
Yes.
during the peak time when power is not available,
Yeah,
okay,
yeah.
or there is no system as on that power is still not there
Mhm.
accordingly. But they can charge from their own solar system, or they can take power from the grid also. It depends.
Sir, one more question. In this discussion of flow batteries, you said one word, long discharge. So,
Yes, yes, yes.
what does that mean, sir? Self-idling discharge or?
No, 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 no. It is not self idling. Long discharge means they stored energy. Okay,
Mhm.
so again, if you want to discharge, maybe the discharge cycle we have studied, like LFP battery showing the 95% depth of discharge, for example, they said.
Okay. Uh-huh.
So storage backup is 4 hours. It can go up to 6 hours or 8 hours. They can store energy up to that hours, like that. Means, for example, lithium ion battery is there. So
Yes.
I just store for 4 hours, maximum 6 hours, you can say. Okay,
Mhm. Okay.
and during the peak hours, again we take the power from BSS. But in case of flow battery, we can store power, and they can discharge up to they can store or discharge up to 6 hours. They can give power. Backup is up to 8 hours, 10 hours, 12 hours also, like that. Means their energy density and power density is far better than lithium ion, we can say, because they are stored in the tank. This electrolyte is stored in the tank, basically.
So the backup time will depend on the load requirement. No, if the load requirement is high,
नहीं, तो वो
obviously it
high
will.
होगा ना. That will be high ना. That will be for commercial purpose, for big projects, basically. It is not for small projects, basically.
Mhm.
Directly connected with grid, basically. This is they are mainly for grid stability or whatever at a high level.
Means, sir, just for a,
Capacity is very high.
suppose this you are saying this 125 megawatt standalone battery. Okay, suppose it is a lithium ion battery. I'm charging it to its full capacity. Now I'm not discharging it. So up to how much time it can save the energy? Like after what
Some
maximum hour I can draw
it
energy
can
from the
save. It
battery?
can save. Na, it is already said. Na, कि only 1% in per month. Idling charging is only 1%. This is here, this one. Self
Mhm.
discharge rate 1 to 2% per month. So once you have stored, the energy will be stored itself.
It will be stored. So just now you
we
use the
can we can see like that. We can see like that our mobile. If we charge our mobile 100%, okay, or we are
Mhm.
not using means we have stopped the mobile data, okay, any Wi-Fi, everything is stopped. There
Mhm.
is then what happens? We see na that we are not using means very less discharge is there.
Yes.
If we are using it, then only discharge na. Idling there is no discharge.
Okay, just now you said that it will use for 6 hours. So what
Which
is
one?
that?
Which
Just
battery?
lithium ion or flow batteries. You said that the discharge it will store energy for 6 hours, something like that. You
No, no,
said so.
no. I'm not saying 6 hours means we
Mm-hmm.
can go up to 4 hours. In lithium ion, we go up to only 2 hours. If we see our tenders, okay, in tenders also either they are like that, either four times, means 1000 megawatt and 4000 MWH, or
Mm-hmm.
50 megawatt 100 MWH, means 2 hours storage is there, either 4 hours. I have not seen 6 hours storage till
Okay.
now.
Okay. Okay.
Okay. But in case of flow batteries, we can go up to storage up to 10 hours, 12 hours. That I am telling this.
Okay, sir. Okay.
Yeah. 1 minute, hold on. Just excuse me. Yeah, sorry. Just okay. These are the key components of SECI BSS tender: capacity requirement, technology specifications, what type of technology we are going to use, project scope. Like in BSS also, no, what type battery we are going to use, where we are procuring, project scope and deliverables, key highlights of RFS document, permitting regulatory approvals, costing breakdown, capex and opex, incentives and government benefits, energy storage obligations, penalties for non-performance like CUF, also for separate if solar PV is there, solar PV or wind or whatever, and for peak hours also, if we have to 4 hours battery energy storage is there, then during the peak hours if we are unable to give the power to the grid, the penalty is also there. Okay. Action plan for SECI tender participation, that all we know. Carefully review the request for selection RFS document for technical, financial, and regulatory requirements. So there are single two envelope, single stage bidding is there. So means technical, financial, and regulatory requirement we should know. Collaborate with Indian or global BESS manufacturing for cost-effective solution. Before tendering rate or whatever, we have to know about where from we are procuring the BESS. Yeah, how we are going to assemble in India itself. What we are importing, or if we are going with only Indians only, that we need to see. Engage EPC contractor with expertise in installation is also important. What installation costs are coming depend on which site we have fixed. Okay, in large scale BSS project basically. Cost analysis, prepare a detailed financial model including capex, opex, and potential revenue stream. Revenue stream also in BSS case there are different things are there. Like energy arbitrage is also there. Means when like rate of energy is going on 3 rupees per kW. At times you just store energy in your BSS, and when demand is there, you sell that power. If you stored energy is there, you can sell the power. It is freedom in India itself. Okay, so you can sell in 6 rupees per kWh. So ultimately, it's energy arbitrage. You can benefit from that one. That is also there, and also if it is committed ki 4 hours you have to be during peak hours, you have to give power. Any problem from the grid side is there, many transmission system problem or whatever, if there is no uptake, then they can still they will provide you the payment. That is also there. Okay, it is not, sorry, it's you have stored energy through your solar PV, and it is not used. Means due to like a grid is available there, there is no demand is there. It doesn't mean nothing is paid to you. That is also there. Submit a well documented proposal showcasing technical expertise, compliance, and cost competitiveness. Statutory requirements for grid connected BSS. CIG, ultimately it is also electrical installation. We have to take CIG. Grid connectivity, it's the responsibility of developers. Okay, frequency, reactive power, harmonics, load dispatch center, we have to take permission. Discom again for connectivity agreement and scheduling. BIS standard, yes, that is much important. Right now, there is no standard developed as on date, but the standard of for inverter or UPS, whatever available, that are all only used for the battery and inverter. Already we are using UPS, and that one, that is also specifically there is no standard developed as on date from BIS. Safety standard. It is also a question that if we are importing from China any PCS, for example, PCS means power conversion system where inverter is there. So BIS is applicable or not? That is again a question. Right now, I just asked someone it is applicable or not, but it is not mentioned anywhere. Right now, whatever the international standards, because there is no manufacturing of BSS as of that in India itself. So whatever the internal standard is there that we need to follow. Otherwise, two standards are there for battery and UPS or inverter that we have to follow. EAI, PCB or safe disposal, fire safety, that is an NFPA 855, ESO, energy storage, electric regulatory commissions, whatever the CRC guidelines, or if you are installing the state SCRC guidelines, cyber security protocols, grid code, battery waste management pollution control board, it will be applicable. Once the battery life is gone, that how we are going to dispose it, that is also important. Comparison of BESS scenario. Okay, I have made a sheet. Three types of BESS tendering scenario may be there. Like one is the standalone, other is the BESS with total solar PV only. Third one is the BESS with hybrid, solar and wind. Okay, what will be the scenario? Tender requirements. Storage only means 120. For example, 125 megawatt, 500 MWh means 4 hours storage is there. Okay, this standalone only this. BSS solar plus storage. In this only this we have to install only this one. I just example is 125 megawatt 500 MWH. The rating of BSS is given like that. 125 megawatt means it can deliver 125 megawatt continuously 4 hours. Yeah, this is the meaning of this one. First of all, yes. Any question?
No, sir.
Okay. And other is the BSS with solar PV. Then we have to install solar and storage. Again, the question will come. For example, storage is there. This one, for example, 125 megawatt, 500 MWH, and another solar capacity in tender is given 1000 megawatt. For example, 500 megawatt we can assume. Then how much solar PV capacity we have to install to for this to comply this storage also, and EA well, battery energy storage for storing charging it, and as well as to dispense the power to the grid at whatever the contractual CUF, say 25%. Then how much total solar PV capacity is used? In last webinar, there was a question. I have cleared this one. We will calculate right now. Okay, next slide. So BSS with the, in case of a hybrid, we are doing solar and wind plus storage. It is assumed that if we install 50-50%, this is the optimized condition basically. With storage, if we are going with hybrid, then if we go with 50-50, then it becomes more viable and optimized. Because wind is available 24 hours, solar is only 8 hours, 6 hours mainly, you can see. Key objectives, we all know, in standalone condition, में grid stability only and peak management. With solar, farm power also we can get added solar intermittency because energy storage system is there. In night there is no solar, but we can continue get power through BESS. So intermittency impact we can be reduced. Wind reliable 24 by 7 because wind is also there. Wind is 24 hours. What in night time, for example, solar is not there, so we can maintain this one through BESS. Continuous power round the clock. Charging short grid or external. For standalone BSS, either we can charge through the grid or any external means we can install solar system, solar PV. If small be is a 1 megawatt minimum for commercial purpose, for interstate means central level, we have to go minimum tending 50 megawatt. Or for only interstate, we can go up to 1 megawatt minimum. Minimum 1 megawatt is necessary for BSS tender. Solar PV during daytime, like this one.
Sir, how
Charging
much
solution.
cost,
Yes,
sir, per megawatt in base?
cost. I am coming. My next slide. There is a cost we are discussing. Okay, in each scenario we will discuss. Costing is also coming. Okay. Which scenario you are talking?
Cost wise, sir, asking.
This one. We are discussing per MWH cost is calculated. Okay, I will tell you. Because there are different scenario. Na? You are importing or you are assembling in India. Battery you are procuring because battery is there. Ultimately you have to import. Battery is there, but it is costly. Okay, solar PV during that time that we are discussing. The next slide, the costing part is there. It will be better with slide. We will understand that one. Okay. Capex, OPEX, medium. This is high because solar. Dispatch profile for grid balancing and instability. Daytime of peak, evening dispatch. BSS is there. The evening there is no solar. After 6 p.m. you can say through BSS we can supply the power. Okay? Evening peak time. Fully dispatchable. FDRE. For FDRE, in case of FDRE means farm and dispatchable power, renewable energy, we can go with this BSS with hybrid, solar and okay, storage is also there, solar is also there, wind is also. Fully dispatchable round the RTC tender or FDRE tender, we can go with this BSS with hybrids. Means storage, other storage also we can go. But if we are talking about BSS, then BSS with solar and wind. Developer challenge. In case of BESS standalone, securing viability gap funding. Okay, viability gap funding is there. Wherever the capital cost is high, like offshore wind, this BESS, wave energy, thermal storage, whatever. In the CSP also, the viability gap funding is there. Earlier in 2012, thermal storage means this solar thermal project came, but there was no VGA. Viability gap funding was not there, but now it is there. BSS is solar managing solar intermittency and complex integration. Okay. This is a sample I have considered this RFS okay document where you have to install 2000 megawatt solar PV. Okay, this is same language. Request for selection RFS document for selection of a solar power developer SPD for setting about 2000 megawatt ISTS connected means CTU connected. ISTS means CTUs PGCL connected solar PV power project with 1000 megawatt 4000 MW 4 hours storage energy storage system in India under tariff based competitive bidding. Okay, this is the project. Now we will discuss how what to do, how much capacity solar PV I have to install because 2000 megawatt I have to give. At the same time, I have to store this one also 1000 megawatt minimum for 4 hours. Every day, 4 hours minimum required because it is assumed every day one charging discharging cycle will be there in case of BESS tender. Yeah, this is see the solar PV capacity calculation for SECI. In last webinar, there was some calculation mistake or something else, but it is corrected right now. So see this slide. What are the key assumption? Grid CUF requirement means if we see this RFS document, it was state that you have to maintain CUF by 25% annually. Okay. Capacity utilization factor. BSS delivery, what should be 4000 MWH megawatt hour per day for 4 hours peak demand. During the peak times, you have to deliver this MWH, itni unit we have to deliver through the BSS. These are the conditions of this RFS document tendering. Now, what to do? So, energy requirement means minimum energy, annual energy for grid. If we discuss about 2000 megawatt, it is coming like that. If you just calculate 2000 megawatt, 24 hours, like that, 6 hours, if we assume 6 hours for solar PV, really, and 365 day, it will come around this one. This is the calculation. This annual energy for BSS charging के लिए how much required? 4000 MWH per day. So 365 you can multiply simply. It will come like this one. You can calculate. So total energy demand, how much? 5, this one. Add both one. It will come this one. This MWH we require per year to comply the CUF for solar PV, 2000 megawatt we have to give. At the same time, we want to charge the battery also every day with same 2000 megawatt, not possible. In that case, you will fail to comply the CUF because Right now, what are the modules or technology we are using in solar PV or total hours solar available? Average CUF coming around 22 to 20, maximum 25% it is coming. So you cannot go up to that.
Sir, one small doubt.
Yes, yes.
Sir, when we talk about this 25% CUF, that is specified in the tender document. Number one.
Yes.
Number two is when we go for larger module size, like 570 or even 600 watts. This is possible. Am I right or wrong?
Yes, yes, you are very right. Now in module also new technology module
Yes.
coming
Topcon,
with higher
bifacial, and
capacity.
all that.
Topcon
Okay.
it is higher than Topcon. HDD type some name is
Okay.
there.
Fine.
It is
Fine. Thank you.
coming. It is coming with 26% CUF basically.
Okay. Fine.
Okay.
Thank you.
So
Thank
in that case, no doubt the technology upgrading and definitely they are committing it will give 26% efficiency basically module efficiency. Okay.
you. Okay. Thank you.
So, yeah, and depend on the site also, which state you are selecting for the site. That is also technology and other things.
But again, sir,
Wind,
one more thing.
module cleaning. You can
I
say,
know, I
yeah,
understand,
yes,
sir.
yes,
But problem is that CTU, capacities are more or less full. Especially Gujarat, Rajasthan, Karnataka, they're all coming up in stages up to 2030. They're given a list of CTU substations with effective date of connectivity. Last
right, right,
month it was published. Now,
yes.
if we have to connect, and we are talking about 2,667 megawatt just to be connected to CTU grid, the connectivity will become a big issue, sir. Maybe we'll have to look at
Yeah,
more than
that
one
is a
state.
challenge. That is a challenge already in renewable energy project, either it is solar or wind,
Yes, sir.
connectivity, land, and execution. Even
Yes, sir.
execution is due to ROW. You can say execution is also getting delayed. PPA
Yes,
is
sir.
also another issue. Curtailment also is another issue.
Yes,
These
sir.
are the major issues in India as
Okay.
on date
Yeah.
regarding renewable energy projects.
Yes, sir.
Okay. So connectivity is where the land is available.
Connectivity is
Connectivity
not
is
there.
not there. Where
Correct.
connectivity available, but land is not there. This is
Okay.
the
Fine.
discrepancy is there.
Yes.
Yes,
Thank
I
you.
can understand that.
Okay. Thanks.
Bhavani sir, sorry for disturbance. I was
Yes.
not there. I was some work. Can you explain from top of this slide, please? Please, sir, I requesting you.
Which one, sir?
Solar PV capacity calculations for SECI RFS from top.
This one. Ah, this one,
No,
na.
yes, yes,
That
yes.
I'm
This
doing,
one,
na.
this one.
Huh?
From top, from starting one. Can you explain again, please?
Okay, okay, no issue. I'm repeating again. Grid CUF requirement means if you see this tender document, this RFS document, you will find
Yes,
there is for 2000 megawatt solar PV dispatchable power. It is stated there that you have to maintain 25% CUF, for example. Okay, it is stated there. Okay, in that case, whatever the technology you are going to use, which state you are going to install, whatever, but you have to maintain 25%. It means if you are installing 2000 megawatt, 6 hours is fixed. If you do everything okay, then only the CUF. So right now CUF we are getting in solar, it is coming at 18% to 22% or
yes, yes.
23% like that. So if 25% quoted there, mean you have to go with that technology. But for that 2000 megawatt is consumed. Well, daily, no doubt you can charge this one also, but ultimately you cannot comply na, with 25%. If every day you charge with this 2000 megawatt only, with this 1000 megawatt, 4000 MWH battery also you charge, so you will not comply with 25%. So which
Yes.
you need to annually, you need to average, you need to sona. Okay. So what I'm saying, it is calculated like that. Minimum annual energy for grid means 2000 megawatt at 25% CUF, daily 6 hour, 365 days. How much you will deliver? This unit you require to deliver. Okay, to the grid for the 2000 megawatt. Yeah, this one again. See this one. This RFS document you see. Request for selection of solar power developer setting up to 2000 megawatt ISTS connector solar PV power project with 1000 megawatt oblique 4000 MW. Don't confuse this 1000. This is confusing basically. You just see this one. Battery energy storage system is 4000 MWH we require energy. Means this is simple calculation ki for at least for 4 hours we need 1000 megawatt. This is the
Yes,
thing.
yes.
Either you are using with this one through 2001 if it is installed at only one site, okay, that depends on that one. Understood na?
Okay. Okay. Yes, yes.
And another thing is the annual energy for BESS charging. But how much power we require for BESS charging? Right now, we are not discussing about how much capacity I have to install. 2000 to you have to go.
Mm.
2000 megawatt solar PV you have to install. That is fixed. But if you are installing BESS also there, that is also required charging kWh.
Yes.
That is calculated
Yes, yes.
again 4000 MWH per day. Into day guys means you have calculated into 365. If you multiply, this will come. Anyone can multiply 4000 into 365. So this will come. Okay. So total energy demand will be to give the grid. Okay, separately 2000 megawatt is there for that one, and to charging the this one. It will come this one by adding both things. Okay, it will come this one. Means you can say how much 58 lakhs 40,000 MWH per year. It is the requirement. Now come to solar PV capacity requirement formula. Means whatever the capacity megawatt total N1 energy demand, okay, per year into CUF. So required capacity will come to 2667 megawatt. Anyone understood this one or again missed problem? You got this one?
Kindly repeat one, sir, if you don't mind, sir.
Means minimum annual like 2000 megawatt if we run continuously, okay, for 6 hour daily solar is there and continuously we run for 365 days, then we will able to maintain whatever the latest technology we are using, we will able to maintain the 25% CUF. Okay, that is one thing. Now at the same time you have to supply 1000 megawatt for 4 hours on daily basis. मतलब 4000 MWH daily you require. How
Right, sir.
how, how you will charge the battery daily one charging discharging cycle is there. So how you
Right,
will charge? You will use the same if you use the same battery, okay, same solar capacity, so your CUF will be down annually.
right, right, sir.
Right? So for that, what we have to do, it depends on you. You go or not go, but penalty will be there, na? Simply.
Okay.
In that case, penalty will be there against the CUF basically. That penalty is also shown there in last webinar. I told you. So total demand is calculated. This unit we require per year. Accordingly, to maintain the 25%, how much powers we require, that is calculated. It is 2667. But what I am saying is a roughly you just keep only 2000 megawatt itself. Okay, if you go with higher, like you have quoted 25% as a contractual, and your technology or whatever you are maintaining up to 27% or whatever, for example. Okay, so you can use that power to charge this battery itself. No need to go with extra solar system. But what calculation is coming? It is coming around 2667 megawatt. You can consider this demand with this annual enable BSS charging. This is a separate. What to be done for this one? Simply you assume that we have to supply this unit on per year. What to do for this one? Okay, you can understand this one. So a minimum capacity of this is mega needed to comply with both grid CO of 25% and BSS charging of per day. Any confusion? I think again confusion is there, but third webinar will not be open. Hemraji, are you there?
Yes, sir, I'm there.
You will tell me, sir, another webinar need to organize. Huh?
No, no, sir. I have
We are,
some
I'm
questions.
tired.
I will ask
Now I
again.
am tired with VSS. Now I will change the subject. I am coming with project management of wind and solar. Okay,
Yes,
next
sir.
project will be the project. Next topic will be project management in wind and solar projects. That is also important, ना? VSS बहुत ज़्यादा हो गया है अभी.
Their importance, sir. The meantime, the mini grids is there, no? That also is.
Yes, yes, yes. These are the BSS is for mini grid basically. It is for mini grid. You can say where that is a part of DRE means distributed renewable energy.
Bhavani sir, I have share a picture of a standalone BSS tender, okay, tracker 2022 to 2024. Can you open on WhatsApp and can you clarify that there is some winning quote of some big players on standalone BSS tenders? So I need to clarify that how they calculate their pricing for that. Okay.
Okay. So you need that document.
No, I have that document. Okay, I have just shared on your WhatsApp. I just need to know how to calculate that pricing. Okay.
Okay, okay, okay. You just share me, no issue. And we will discuss.
Yes, yes, yes.
And
I
next
have
time,
shared
what
you on
I'm
WhatsApp.
doing, next time what I'm doing, we will make a WhatsApp group, whatever who have participated in the webinar. So further, whatever we have discussed in the webinar, if any confusion is there, we will discuss there and close it. Okay, all will be at one place, then we can discuss and close that one. It will be better technical discussion.
Okay.
Okay, so this is the last time someone asked me. I think I want to understand the levelized cost of electricity. Who asked me? Is there or not?
Yes, sir. I have asked for LCOE.
Yeah, you only asked me. Okay. So
Yes.
for you, I have done this one. Assuming this one only means same example 2000 megawatt and 1000 oblique
Okay.
4000 MWH. Same example I have taken for calculation. So this is the levelized full cost of energy. Okay, complete. I have changed the technology and the word LFCOE. ठीक है? Levelized full cost of energy. Because here many other factors are also there. We are just only calculating if capex and opex doesn't work. Some other factors also there. Okay, so assume solar PV capacity 2000 megawatt plus 667 additional we are assuming for our safer side as far as BSS battery charging and to deliver the 2000 megawatt to grid at the rate of 25% CUF. Accordingly, I consider this one. BESS capacity is 1000 megawatt public 4000 mega MWH. It is given in the tender document. Solar capex, I assume 3.5 crore per megawatt. It is okay. BSS capex
Yes,
4
sir. Yes,
crore
sir.
per MWH.
Sir,
Yeah, yeah.
sorry to interrupt. Sir,
Yes, sir.
land cost, how much you have considered for the solar at 3.5 crores, sir?
No, no, actually, I just simply idea. It may be 4 crore also.
It
Okay.
is more than that, sir, because good
Ah,
area land is going
yes.
up, and if you are nearer to the CTU substation, the land cost goes up to around 70, 80 lakhs per acre, sir.
Yes, yes, yes. That is
So
a
that
that is,
means that this 3.5 crores per megawatt will automatically go up to 4 or 4.5 crores per megawatt.
this will go up to 4.5 also.
Yes,
4
sir.
crore we can
Yes,
consider
sir.
that.
4 crores
4.5
is possible, sir.
because this is the 1000. I mean, it's a big project, 2000
Yes,
megawatt. Okay, that's
absolutely.
why I optimize it to 3.5 crore per megawatt. Basically,
Okay,
if we
because you
discuss
can,
our
yes, you can
yeah,
save on
if,
the electrical and the civil works, definitely, because the size is larger,
yeah,
the contractor will give you a lower rate.
economy actually we are getting benefit
Yes,
of economy of scale. Like
perfect,
if
sir.
it's more about Khavda
Yes,
for this Rani project,
yes,
so
yes, yes.
the cost will be automatically reduced for them.
Yes, absolutely right,
Like
sir.
that.
Right, right, right.
That's
Thank
why
you. Thank you. Thank you.
BSS capex 4 crore per MWH. Okay, someone is asking me na, what you have considered for per MWH 4 crore. Okay, project duration 25 years, CUF 25 annual, discount rate 7%. Okay, and viability gap funding 50 lakh per megawatt. This is a VGF for BESS project, 50 lakh per megawatt. Our is the 1000 megawatt. Okay. Arbitrage revenue. Arbitrage, I told you, na, means you purchase, charge your BSS when grid is available, rate is very low, only rupees 3 per kWh. At that time, you are charging. And when you are discharging, when there is a demand, rate is high, then you are giving the 6, okay, 6 per kWh. This is the arbitrage, or it is this is the facility in this BESS tender. Means you can also sell the power.
Yeah, absolutely. Sir, one doubt, sir. Uh,
Yes, yes.
in this, capex and this calculation for the BESS, you not consider the degradation of the batteries, no, sir? Battery should degrade and we may have to replace it periodically. That cost has to be
Yes, yes.
included, no, sir?
After 15 years, I am assumed as a replacement. If we have a total life cycle, we consider 25 years. Then
Okay.
after 15 years, I have assumed the replacement.
Okay,
Uh,
fine. Then okay. Okay.
more calculation is coming next slide.
Oh,
Okay. See here, the total solar capacity to 667 megawatt, total solar capex after VGF 8334 crore. Total BESS capex 16,000 crore. How it is calculated? Uh, in previous slide, you see 4 crore per MWH. It will come 16,000 crore. BESS
Yes, yes, it is
replacement.
okay.
Sir, you are asking the BESS replacement cost battery 9,600 crore. 15 years, after 15 years. This is this one. I have considered here. Battery will be replaced. 10 years warranty is given by the OEM, but 15 years I have assumed here. The total O&M cost 2% or water 403 3.5 crore per year. Okay, solar plus BESS 2% I have assumed around of the capex. So annualized cost and LFCOE मतलब leverage cost of आपका electricity है ना, levelized cost of electricity, full cost of electricity, annualized capex coming 2945. You can take the screenshot also, and if any confusion you can ask later also. Okay, annualized capex, this one, total annual cost after arbitrage, because arbitrage is benefit, it's a revenue streaming for us. This one, total annual energy supplied, this one, MWH per year. So cost is coming 3.99 per kWh for the 25 years, and assuming after 15 years replacement of battery or whatever BSS replacement cost, you can see. So
Sir,
conclusion.
LFCOE is 3.99 rupees per kilowatt, but how to calculate this, sir? How to come 3.99 per kilowatt?
अरे तो ये बताया ना वो सारा, तो ये देखिए, आप टोटल सोलर कैपेसिटी दे रखा है. ओके, मींस आपने केपेक्स,
Okay,
यू हैव फर्स्ट यू हैव टू कैलकुलेट केपेक्स. ओके, सेकंड you have to calculate opex, then third one is the, we have calculated opex and capex both for solar and BESS separately. Then what are the
okay,
revenue streaming? Means we are generating also, na? We are giving power to the grid, 2000 megawatts separately at the 25% CUF, and for 4 hours storage we are giving power to the this one grid. Okay, during peak hours, and arbitrage benefit is also there. Viability gap funding is also there. But in this case, I have not considered viability gap funding (VGF). Next slide, I am considered that one. Okay. This cost is okay, but in payback, I have two slide I have made. One without VGF or one with VGF, like that. Annualized cost, you got it or not, Hemraji?
sir, everything is okay, but I am confusing about that. LFCOE is 3.99 rupees per
इसको
kilowatt.
you
I am
you
just
you
confusing.
you just tell simple है फॉर्मूला सर, कि मेरा कोई प्लांट मेरे को लगाना है 2000 मेगावाट का सोलर लगाना है,
हम्म,
और साथ में मुझे एक बैटरी एनर्जी स्टोरेज सिस्टम लगाना है 1000 मेगावाट का, जो हर चार चार घंटे तक मुझे 1000 मेगावाट देगा, और मुझे
हम्म,
4000 MWH चाहिए मेरे को कुल मिला के. ठीक है सर,
Okay.
डेली। तो अब ये दोनों जो चाहिए, तो उसका एक तो कैपिटल कॉस्ट क्या आएगा दोनों का, ठीक है, वो अब
Okay.
मैंने निकाल लिया, पीवी का निकाल लिया, बीएसएस का निकाल लिया। फिर इसको मुझे ऑपरेशन मेंटेनेंस भी करना है, ओएनएम करना 25 साल के लिए, तो उसकी कॉस्ट क्या आएगी, सोलर पीवी की क्या आएगी,
Okay.
बीएसएस की क्या आइएगी, वो भी निकाल ली। फिर मेरे को तीसरा है कि 25 साल की लाइफ टाइम के लिए, पूरे लाइफ टाइम के लिए कैलकुलेशन होना, 25 ईयर्स अपन एज्यूम करते हैं, सोलर और इवेंट के कोई भी प्रोजेक्ट हो, तो उसका जो लेवलाइज कॉस्ट ऑफ इलेक्ट्रिसिटी जो निकालते हैं वो 25 ईयर्स के हिसाब से निकालते हैं, ठीक है। तो उसके लिए 25 ईयर्स की कैलकुलेशन है, मुझे 25 ईयर्स तक, कैपिटल कॉस्ट तो एक बार ही लगेगा, लेकिन ओएनडीएम मेरा 25 ईयर्स तक करना है। तो सोलर पीवी का तो 2% मान लिया, या मैंने 1% मान लिया, 1.5% मान लिया केपेक्स का, वो मेरा 25 साल तक ईयरली है, तो 25 साल तक मैंने उसका कैलकुलेशन कर लिया, ठीक है। और दूसरा मेरा जो बीएस है उसका भी 2% है, ठीक है, कि 2% उसका केपेक्स का, तो वो भी 2% मैंने पकड़ लेंगे। 15 साल तक वो रहा, और 15 साल के बाद उसको रिप्लेस करना पड़ गया मुझे, क्योंकि बैटरी की लाइफ ही इतनी है, तो वो पूरा रिप्लेसमेंट की भी कॉस्ट अगेन जस्ट लाइक कैपेक्स ही होगा, मतलब रिप्लेसमेंट मान गया ना, आपको पूरी बैटरी चेंज करनी पड़ेगी। वो तो उस टाइम तो कॉस्ट लो आएगी क्या आएगी, लेकिन आज की डेट में अपन एज्यूम करके चलेंगे ना उसको, उस टाइम तो
Yes. Yes.
बैटरी की टेक्नोलॉजी, केमिस्ट्री चेंज हो जाएगी, शायद सस्ता हो जाएगा। आज लिथियम में जा रहे हैं, उसमें टाइम हो सकता है सोडियम आयन में जाए अपन, तो दैट इज डिफरेंट थिंग डेटा। तो ये सारी कॉस्ट आपने जब ले ली, अब आपका आता है दूसरा पार्ट, ये मेरा खर्चा पूरा आ गया, मैंने पूरे 25 साल के लाइफ के लिए, लाइफ साइकिल के लिए टोटल कॉस्ट निकाल ली। अब मुझे रेवेन्यू क्या आएगी, तो एक तो मैं 2000 मेगावाट 25% सीयू में मैं मान लिया उसको दे रहा हूँ ग्रिड को, उसकी कोई रेट फिक्स है, ठीक है ना, उस रेट में मैं उसको दे रहा हूँ। और फिर मेरा दूसरा है कि मैं ये जो दूंगा क्या बोलते हैं,
Battery.
आर्बिट्रेज बेनिफिट भी है मेरे को, कि जो मैं पावर सेल करूंगा वो और दूसरा मुझे वाइबिलिटी गैप फंडिंग के नाम पे कैपिटल सब्सिडी मिल रही है, वो भी मेरा है। तो वो सारा कैलकुलेशन करने के बाद आपको, सॉरी वो तो कॉस्टिंग में हो गया, ये आपका रेवेन्यू क्या क्या हुआ, मतलब जो आपने सेल किया पावर, और ये आर्बिट्रेज वाला बेनिफिट, ये सारा मिला लो आप, वो सब जोड़ लो, वो रेवेन्यू हो गया। एक आ गया आपका कॉस्ट 25 साल के लिए, और 25 साल के लिए आपने रेवेन्यू क्या है। तो सिंपल आपको निकालना है कि लेवलाइज कॉस्ट ऑफ इलेक्ट्रिसिटी, मतलब अब आप निकाल लेना, आपने कॉस्ट पता लग गई, रेवेन्यू पता लग गया, तो वास्तव में मेरा एक यूनिट, मतलब पर यूनिट कॉस्ट मेरी क्या है, लेवलाइज कॉस्ट क्या है, वो आप रेवेन्यू माइनस कर दो तो वो कितना बचा, ये समझे आप। एक मिनट, ये आपका स्लाइड में आप देखिए, ये यहाँ पे अपन ने पहले निकाला बीएसएस का वो कॉस्ट निकाल लिया, फिर एनुअलाइज कॉस्ट एंड ये एनुअलाइज कर दिया उसको, ठीक है, ये आ गया।
ठीक है.
उसके बाद ये तो क्या सीधा मैं कैलकुलेशन आपको दिखाता तो समझ में आता है, शायद आगे है कैलकुलेशन, थोड़ा बेटर समझ में आएगा, ठीक है ना, पे बैक वाले में उसको निकालता है तो बताइए। अल्टीमेटली मैं इसका वही है क्रक्स, कि यू हैव टू कैलकुलेट केपेक्स फॉर द 25 ईयर्स लाइफ साइकिल के लिए, उसमें बैटरी एनर्जी स्टोरेज सिस्टम के लिए स्पेशली यू हैव टू कंसिडर दैट आफ्टर 15 ईयर्स यू नीड टू रिप्लेस इट, स्पेशली बैटरी, दैट इज आल्सो ए कॉस्ट। देन रेवेन्यू के दूसरा जो आपको कैपिटल सब्सिडी जो मिल रही है, मींस वायबिलिटी गैप फंडिंग, दैट यू नीड टू कंसीडर इन उसको कम करना पड़ेगा आपको, ठीक है। तो वो आपका कॉस्ट नहीं लग रहा है एक तरह से, तो दैट यू हैव टू नीड टू कंसीडर दैट। आर्बिट्रेज जो बेनिफिट हो रहा है, व्हेन रेट ऑफ पर केडब्ल्यू इज लेस, एट दैट टाइम यू आर चार्जिंग द बैटरी, और व्हेन रेट ऑफ हाई हिमालय एनर्जी, उसमें जो उस टाइम ग्रिड में उस टाइम आप सेल कर रहे हो किसी को, वो आपका, क्योंकि आपको इसको एक तरह से दे दिया इसमें बीएसएस टेंडर में, इट इज क्लियरली स्टेटेड दैट यू कैन सेल द पावर, ओके, किसी थर्ड पार्टी के साथ भी आप कॉन्ट्रैक्ट, आपको तो 4 घंटे 1000 मेगावाट 4 घंटे के लिए देना, बस वही उतना ही आपका उसमें कॉन्ट्रैक्ट, उसके अलावा आप एक्स्ट्रा देते हो, यू कैन सेल टू एनी अदर्स आल्सो, ठीक है, दैट इज आल्सो। तो वो एक आर्बिट्रेज का बोला कि 3 रुपए में आपने खरीदा, चार्ज किया बैटरी को, और जब 6 रुपए में आपने उसको सेल किया, दैट इज आल्सो रेवेन्यू जनरेशन। वो सारा कैलकुलेट करने के बाद ये आपका निकाल लिया टोटल एनुअल एनर्जी इतना है, तो टोटल एनर्जी, तो लेवलाइज कॉस्ट ऑफ इलेक्ट्रिसिटी कम्स पर केडब्ल्यूएच, आपकी वास्तव में कॉस्ट क्या है निकल जाएगा ना अब तो आपके। वही कमाया मैंने, खर्चा कितना किया और बचा मेरा, कमाया क्या है, तो कॉस्ट तो निकल जाएगी मेरे, कॉस्ट कितनी पड़ी पर के डब्ल्यू एच। ठीक है सर,
वो तो सही है सर, लेकिन एक थोड़ा एक क्लियरिफाई में एक आती है ना
करेंगे
कैलकुलेशन
करेंगे
सीट, तो वो
सुनिए,
ज्यादा बेटर रहती है।
आपको आपसे क्या 1 to 1 बात करनी पड़ेगी मुझे, ऐसा
सर वो
लगता है।
फॉर्मूला बता दीजिए ना डायरेक्ट, एलसीएफओई का मतलब
हम्म।
कॉस्ट माइनस रेवेन्यू डिवाइडेड बाय, और व्हाट इज लाइक
हाँ,
दैट।
एक मिनट कर लेते, चलो इसको एक काम करते हैं, कैलकुलेशन ही करते हैं। अभी आपका टोटल ये आ गया, बीएसए रिप्लेसमेंट कॉस्ट, टोटल ओ एंड एम कॉस्ट, ओके, सोलर कैपेसिटी हो गया, बीएसएस, ये इन दोनों को ऐड कर लीजिए, और रिप्लेसमेंट कॉस्ट ये भी आएगी, एंड टोटल ओ एंड एम कॉस्ट आएगी, टोटल कॉस्ट हो गया सोलर प्लस बीएसएस, ओके। टोटल ओ एंड एम कॉस्ट देता है ना, और एनुअलाइज कैपेक्स आपका आ गया, एनुअलाइज निकाला इसने तो 2945.415 तो आ गया आपका टोटल कैपेक्स, ओके।
ओके।
आर्बिट्रेज से माइनस करने, हाँ आर्बिट्रेज, आफ्टर आर्बिट्रेज इट इज कमिंग 2910, ठीक है। टोटल एनुअल कॉस्ट आफ्टर आर्बिट्रेज 2910, ये हो गया आपका टोटल कॉस्ट लग गई आपकी, ठीक है सर। इट इज पर पर एनम ये कॉस्ट आ गई 2910 करोड़, और टोटल एनुअल एनर्जी सप्लाइड कितनी ये है। अब आप इसको ऐसा करिए, जो सप्लाई हुई है इस, हाँ, तो इस कॉस्ट का इसमें भाग दीजिए आप, क्या आता है।
2910/25।
हाँ हाँ हाँ, नहीं 73 जो है ना आपका, 7300, ये आपका 73 लैक्स, 73 लैक्स
हाँ।
जो है यूनिट, हाँ ये यूनिट है, इसमें आप दीजिए इसका डिवाइड बाय 2910 करोड़, करोड़ को आप रुपीज में कन्वर्ट कर देना, और ये ऊपर भी आपका MWH,
So it's coming 2507.93. 73.
2910, ठीक है, इसको करोड़ में रखिए, लाख में कन्वर्ट कर दीजिए, कोई बात नहीं। ये हेमराज जी के लिए मैंने सस्पेंस बना के रखा था, नहीं,
यही तो मैं
और मैंने
सबसे
देखा
ज्यादा तो यही
आप,
चीज।
मैंने देखा आप करोगे यार, तो आपने किए लिया।
अरे मेरी हेल्थ भी
कुछ तो
सही
एक
नहीं है
सिस्टम,
सर, इसलिए मेरा, सॉरी।
अच्छा
यस
अच्छा,
यस।
वो मैं देखा भाई थोड़ा बहुत आप करोगे, तो इसलिए मैंने इस टाइप से रखा है इसको, साथ पूरा फॉर्मूला नहीं लगाया, डिवाइडेड बाई 73, किया क्या किसी ने डिवाइड, एनीवन? ये आ गया, अगर इसमें कुछ है, चलो मैं फॉर्मूला अभी देखते हैं, ठीक है ना। इसको अपन वापस आते हैं बेक इस पे, ठीक है, थोड़ा बाद में आते हैं, कोई बात नहीं।
ओके।
3.99 कैसे आया, वो अपने का कंफ्यूजन है ना, कुल मिला के, दैट वी नीड टू
यस यस।
कैलकुलेट ओनली, ओके। ये कॉस्टिंग पार्ट है, कॉस्ट ब्रेकडाउन ऑफ बीएसएस, वही सेम 1000 मेगावाट 4000 MWH का लिया है। ये आप थोड़ा सब स्क्रीनशॉट ले लीजिए, इस पे थोड़ा यू आल्सो कैन डिस्कस, थोड़ा कैलकुलेशन आप भी करना, देखिए इट इज राइट और रॉन्ग। देखो मैंने एलएफपी बैटरी की कॉस्ट निकाली है, ठीक है, ये एक अलग केस, दो केस बना दिए, वन केस इज इट इज इम्पोर्टेड फ्रॉम द चाइना, ओके, if it is imported from the China, or if it is manufacturing in India, assembled in India, whatever. In that case, what will be the scenario of the costing? So LFP battery is coming like that. This is the cost for INR, or this is US dollar. If it is China, it is coming 1,40,000 US dollar. This is basically for 1000 megawatt 4000 MWH. Simply, you can see here LFP battery coming around 70% costing. If you go in India, it comes around 67, very 1 or 2% benefit only. Battery, there is no benefit in India as on that. Compartment, same 2.73%. EMS, 0.75%. BMS, PCS, power conversion system. BMS is also 0.75% costing. Overall costing ka, this one only. PCS, power conversion system, 8%. Fire suppression system, 0.5%. Liquid cooling, 0.99, means 1% around. Installation cost is around 4%. So if we see in rupees, Okay, the total cost of this 1000 megawatt, the biggest confusion in BSS rating is that how to calculate by one. I consider it 1000 megawatt or 4000 MWH basically. That is a big confusion. This is the total cost is coming here. If we import from China per MWH cost, if imported from China, total cost coming this one in Indian rupees. You can convert it uh, lakh also. So it comes around 167, 167 lakhs.
Yes, sir. Yes, sir.
It is right or wrong? It is again wrong.
Just let me.
167 lakhs per MWH.
अम, सर
If
जी
it is,
सर
हाँ
जी
जी,
एक छोटा सा सवाल है।
हाँ
जब
जी,
हम
बोलिए।
बैटरी इंपोर्ट करते हैं उसके ऊपर तो कस्टम्स ड्यूटी लगेगा ही ना सर?
सर ये जो वो अभी जो आप बोल रहे हो बिल्कुल यू आर राइट। जब हम इंपोर्ट करेंगे तो ये जो कॉस्ट है ना इसमें मैंने कस्टम ड्यूटी को भी नहीं इंक्लूड किया जो लगभग 8 से 10% है।
हाँ
ठीक
वही
है
तो
सर,
पूछ रहा हूँ मैं।
वो लगेगा, वो अलग
वही
से लगेगा।
हाँ
उसके अलावा लैंडेड कॉस्ट की अगर अपन बात करें तो लैंडेड मतलब मुझे कहाँ ले जाना, फॉर एग्जाम्पल मैंने मुंबई पोर्ट में मंगाया है।
हाँ करेक्ट, मुंबई से
आई
फिर
हैव टू
आपको
टेक इट,
गुजरात लेके जाना है, उसका
हाँ वो
ट्रांसपोर्ट
लॉजिस्टिक
कॉस्ट
कॉस्ट भी
वगैरह
एक्स्ट्रा
वगैरह।
लगेगा।
यस
बिल्कुल
परफेक्ट।
सर, वो भी लगेगा सर।
यस सर, थैंक
8 से 10% आप कस्टम क्लियरेंस का उसका कस्टम ड्यूटी वो सब मान लीजिए।
यू। ओके फाइन, थैंक यू। राइट।
बट ये वहां से जो इसमें भेजा है वो अदर देन मतलब वहां से जो भेजा है वहां तक आ गया है, लॉजिस्टिक क्लियर अप टू आवर पोर्ट इन
यस
इंडिया, पोस्ट इज
एब्सोल्युटली,
इंक्लूडेड।
वहां से क्लियरेंस एंड ट्रांसपोर्ट इस हमारे स्कोप में
हाँ,
आएगा। करेक्ट।
ट्रांसपोर्टेशन आके अपने पोर्ट पे आ गया। फर्दर कस्टम क्लियरेंस जो 8 से 10% है
यस
और
सर।
लॉजिस्टिक टू आवर साइट
यस।
वो अलग है।
ओके थैंक यू थैंक यू थैंक
राइट। तो ये कॉस्ट आ रहा, तो ये सही है क्या पर MWH वन
सर
सिक्सटी
पर
सेवन लैक्स
मेगावाट
आ
तो
रहा है
1 करोड़ 54
मेगावाट
लाख आ
आवर।
रहा है सर।
हाँ
Here,
कितना?
like I have one question. Like,
Per megawatt is
what
1
about?
crore 54 lakhs for Indian rupees.
Hello. Hello.
हाँ हेमराज जी, ये आवाज कहाँ से आ रही है?
I have
मेरी
one.
तरफ से आ
I
रही
have one
हाँ
query.
बोलिए बोलिए।
Like at present, what is the custom duty? Because as I know, there is on the lithium LFP batteries there is a 20% and 20 and like some education cells and everything which we are going to add, then it will cost around 20 to 23%. But some persons do like it might be 11%. So what is that case?
नहीं नहीं सर,
Because that is
कैन यू रिपीट
also
अगेन?
one of the most important point.
नहीं नहीं, कैन यू रिपीट अगेन सर?
लाइक कैसा है कि जो अपने इलेक्ट्रिक बैटरीज इंपोर्ट कर रहे हैं ना,
हाँ हाँ
तो उसमें जो कस्टम ड्यूटी है
राइट।
वो 22% लगेगा या 11% लगेगा पूरा
नहीं
अगर
10,
कंटेनर वहां से इंपोर्ट?
कंटेनर करेंगे तो लगभग 10% के आसपास आएगा।
हाँ, कौन से एचएसएन के ऊपर?
मुंबई पोर्ट की अगर अपन बात करें ना,
नहीं नहीं, एचएसएन
वहाँ
कोड कौन सा रहेगा? 10%। अगर लिथियम आईएलएफपी का आप एचएसएन कोड देखते हो ना, तो वो
हम्म,
20% का है। तो ये
अच्छा
10% वाला कौन सा एचएसएन है कि जिसके ऊपर अपने 10% पे कर सकते हैं? मेनी पीपल से लाइक 10% पे हो सकता है, बट वो कौन से एचएसएन कोड के ऊपर?
ओके। ये दिस इज गुड क्वेश्चन, बट आई हैव टू क्लियर दिस वन
क्योंकि
वेयर इट इज।
अगर यही कैसा है कि वो दोनों के ऊपर ही 10% का कॉस्ट इम्पैक्ट है, और बड़े प्रोजेक्ट्स में 10% इज वीक अमाउंट।
नहीं नहीं, ये तो बहुत बड़ा है ना। अभी जैसे आप आपका कॉस्ट जो CIF की अगर बात करें 1 करोड़ के आसपास है, तो 10% बहुत ज्यादा हो जाता है देखा जाए तो।
बहुत ज्यादा।
हाँ, तो वी नीड टू रिव्यू इट।
हाँ।
ठीक है सर, मैं ये बताता हूँ इसका क्या, क्योंकि मैं जो जहाँ तक आइडेंटिफाई किया हूँ 8 से 10% समथिंग कस्टम क्लियरेंस का, ये मान लीजिए जो भी है ये कॉस्टिंग आ रहा था अंदाजा।
नहीं, ये जो रहा ना, लाइक आज से 3-4 महीने या 5 महीने से ये इसके ऊपर इतने परसेंट पे बात हो रही है। लेयर
हम्म,
आप देखोगे ना 2024 का स्टार्टिंग या 2023 पे, एट दैट टाइम लाइक पीपल्स आर टॉकिंग अबाउट 20-22%। अभी
ओके।
जस्ट जो अपने टेंडर स्टार्ट हुए इतने सारे, तब
हम्म,
लोग बोल रहे हैं अभी 10-11% के अराउंड वो हो रहा है।
हम्म, ये तो वो
तो क्या
उसमें
ऐसा कुछ चल
सर
रहा है?
उसका मैं वही बता रहा हूँ, वो अगर ऐसा है ना तो बिल्कुल सही कह रहा हूँ। इसमें क्या है कि कस्टम ड्यूटी सब पे रिलैक्सेशन तो है ना इस बीएसएस प्रोजेक्ट के लिए। अपने को आज नॉट ओनली वायबिलिटी गैप फंडिंग, और भी जो टैक्स रिलैक्सेशन वगैरह ये कस्टम ड्यूटी सारा है उसमें, तो हो सकता है उसके बाद 10% बता रहे हो।
हाँ, जो गवर्नमेंट का लास्ट बजट था ना, उसमें जो
हम्म
रिलैक्सेशन दिया था वो था अपना कैपिटल। अगर जो बैटरी मैन्युफैक्चरिंग के जो इक्विपमेंट्स है ना,
हम्म।
वो इंपोर्ट के ऊपर उन्होंने रिलैक्सेशन दिया था।
अच्छा
बट इसके ऊपर कहीं ना कहीं कोई बीच में नोटिफिकेशन आया है कि क्या है, दैट्स आई डोंट नो।
ठीक है सर, इसको क्यों देखते हैं, बात कर क्लियर करते हैं कि ये कितना टेन है क्या है। और जो कुछ एचएसएन कोड का आप बोल रहे हो ना, तो दैट आल्सो वी नीड टू आइडेंटिफाई विच प्रोडक्ट
एक्सेशन
वी
कोड या
आर
गवर्नमेंट का
बीएसएस
प्रोडक्ट है।
में भी कंप्लीट कंटेनर वी आर टेकिंग ऑन। आई थिंक ये कंटेनर के लिए है, ठीक है, फिर भी वी विल क्लियर इट। आपने इंपोर्ट किया है क्या सर कहीं पे अभी?
नहीं नहीं, इंपोर्ट नहीं किया, बट एसएसएन के ऊपर जो भी देख रहा हूँ, क्योंकि अभी जहां जहां भी हम कॉस्टिंग पकड़ते हैं तो वो 22% ही पकड़ते हैं, क्योंकि लिथियम आयन का जो कस्टम का जो है कोड, उसके अकॉर्डिंग तो वो 22% के आसपास ही बैठ रहा है। एजुकेशन सेस एंड ये दूसरे भी जो
काम
सोशल
करो ना, वो जो
सिक्योरिटी।
पाइट्स पाइट्स कंपनी के साथ डिस्ट्रीब्यूशनशिप दिला देते हैं आपको,
नहीं, उसके
ठीक
लिए
है।
अपने अलग से बात करेंगे,
सर जी,
हाँ हाँ
व्हाट्सएप में दोनों
सर
बात
हाँ
जी,
जी हाँ जी। सर बोलिए।
सर जी, ये जो है, यू हैव मेंशन कि वो अलग सा कैलकुलेशन में लगेगा, इट विल ओनली इंक्रीज योर कैपिटल कॉस्ट। बिकॉज अगर 10% लगेगा
हाँ
तो दस
कैपिटल तो
परसेंट के
आएगी सर।
मुताबिक लगेगा, या 22% पे 22% का लग जाएगा। तो दैट कैन बी
हाँ
डिस्कस सेपरेटली, वन टू वन ऑल्सो आप कर सकते हैं ना सर।
जी जी हाँ, बिल्कुल बिल्कुल, ओके सर, ओके
थैंक
यस
यू।
यस।
ओके। सॉरी सर, सॉरी है ना ये दिस। ओके, वी हैव डिस्कस दिस कॉस्ट measure benefit. We can see per MWH cost if imported from China it is coming 167 like that here you can see, and in India it is 151. Difference is not much more as on date. Yeah, the payback. Payback is another thing. There is again a confusion ki what will be the payback, because we have to consider the capital subsidy. This is viability gap funding. Also, we need to consider. Okay, so energy arbitrage, that is also there. That is also the part we need to consider the payback. So in normal solar project, if we see there is no all these arbitrage benefit, these are not there. Okay, whatever is from you have to give that power, extra power if you are putting in the grid, no separate nothing to be paid. But especially for BESS, if you can sell the power, that is the freedom in the BESS tender. Okay, so here key inputs for payback period we see. It is visible my slide, or I have to zoom it?
Yeah, it's visible, sir.
Okay. So based on the total cost of the system, including installation, logistic, etc. For example, imported from China, some cost is one. Okay. Manufacturing in India, both are in US dollar, million US dollar, 805. It is on this. I have taken this case only 2000 megawatt solar PV or 4000 MWH. We are discussing for 4000 MWH basically. Annual operational cost is also there, 2% of capex for BESS. It is only for BESS we are discussing. Okay. Revenue from BESS, arbitrage revenue, revenue generated by storing at cheap electricity and selling it during peak demand. Example, 3 rupees per kWh you are charging cost, and rupees 6 per kWh you are discharging. It means revenue generation, 3 rupees. Annual energy dispatched for 4000 MWH is the our so annually per day you have to this one, so 365 is multiplied. Okay, so you will dispatch so much MWH per year. Net arbitrage revenue here, revenue through this one, 3 rupees difference is there, we are just multiplying. This is coming per year through arbitrage into this what is this one? Okay, arbitrage revenue. Operational cost is also calculated here, 2%. The capex for the BESS also it is 2% of the capex, O&M cost. So adjusted capex with viability gap funding, 4000 to 55 or 50 lakhs per megawatt. 50 lakhs, it is 55. 50 lakhs per megawatt is the in the RFS document is shown. Viability gap funding is there. So for in our case it is 1000 megawatt, but it is calculated in 4000 to 55. Okay, 220 crore. O&M cost is 2%. This one. It is a capex for viability gap funding. Okay, understood. Net annual revenue after O&M cost is the 39.4 crore. Yani if we take 4000 MWH, what will be the final revenue after O&M? It's coming around 39.4 crore per year. This is the overall calculation we have done here. We have considered viability gap funding, which is around, it is written 55 lakh, but I think 50 lakh per 50 lakh per MW. Okay, 50 MWH. It is shown like that. So this is coming revenue after O&M is 39. So payback period formula is simply adjusted capex the net annual revenue. So payback period is 220 crore is calculated here. This one, okay, by adjusting this VGF in capital cost. So it is coming around 4,000 to 50 to 20 crore, and annual 39.4 crore is a final revenue, revenue after O&M. So this coming 5 to 5.5 means 6 years, 6 to 7 years is the payback period. When all these are things are considered, means viability gap funding as well as arbitrage revenue. After that only it will come around 6 to 7 years. Otherwise, it will go up to you can say 16, 15 to 16 years. Yeah, this is another calculation. This is another calculation. Okay, battery cost 50 lakh per MWH. PCS, energy management system, BMS, installation, cooling, fire suppression based on this provided breakup. This according to this one. Okay, and incorporate VGF. Apply 10 lakh per MWH VGF to reduce capex. Okay. You can take this screenshot of this document. Okay. If payback analysis में revenue streams, what are the revenue streams? It is arbitrage revenue again with 3 rupees per kWh. Ancillary service supporting grid stability and provide additional revenue. VGF impact, viability gap funding we have considered already. Break even period 1 to 2 years. That already I have shown in the sheet. What is the LFP battery cost? Around 60 to 70% of total capex. Other key component 8 to 10%. Okay, that we have already discussed all these things. Actually, this is another case which is given by ISGF. ISGF, you heard about that one? India Grid.
It's a smart energy foundation.
Indian Smart Grid Foundation.
Smart Grid. Okay. Indian Smart Grid Foundation. That calculation is given by them basically. You can check this document also. You will find there in their website. Okay. So they have actually given total from 2018 or 19 to till 2032. What will be the scenario? In that, this is calculation is given basically. So total cost of 4,000 MWH BESS imported setup is coming around 1,67,079 crore. Domestic setup 1,50,000 crore. So rupee MWH cost decreases for domestically manufacturing system. A simple calculation they have given. I just put here. It is nothing else. Simply whatever shown in the RFS document. Okay. In the RFS document, single or two bidding, what we have to type e-tender manual, especially for this 2000 megawatt only. That RFS document I have reviewed. Within after RFS, within 20 days, you have to bidder has to report if any discrepancy. Site you can just say ki IS and ETS, single or two stage bidding. This is single stage bidding. Type e-tender. Your manual, so it is e-tender. RFS document fees 50,000, non-refundable. Bid processing fees, non-refundable, 20,000 per megawatt, plus GST or maximum 2 lakh. Okay. And EMD, bank guarantee, just like this is again 16 lakh 24,000. This bank guarantee, just like performance bank guarantee, no, applicable. All dates as per NIT. Okay. Notice inviting tender or as per portal IS and ETS. Reverse action successful withdrawal informed via email. Means reverse action, for reverse action they would only way who clear the technical round. This is the download. Or another thing, PPA for 25 years with SECI on build on and operate basis. Fiscal incentive bidder can avail accelerated depreciation. There are, it is applicable, you can take concessional custom duty. So you are talking about the custom duty. If there is any concessional custom duty or excise duty is there, means especially for this project, that can be availed. Tax holidays applicable for such projects. Any solar power developer already commissioned, if you have already commissioned or under construction any project, you can also participate in this this one. This was mentioned basically. So if you are going for the BESS type tender, if already you are constructing the solar or already you have commissioned but not tied with the grid, you can participate with such tenders and avail benefit of extension of PPA duration between the SCSD and annual commencement of supply. Means already you are, if you are commissioning earlier and your PPA, whatever the PPA date is there, so whatever the difference will be there, you are early commissioning, your PPA will be extended up to that one. No separate financial assistance, whatever the viability gap funding is there, separate CPA is the central financial assistance is not there. A single stage, two envelope bidding procedure, techno commercial bid, financial bid. Okay. Another thing is power evacuation is the responsibility of the solar power developer only up to the point of intersection in the ISTS pooling station. Land is our land, solar PV or BSS technology, whatever it's depend on what who is the bidder. He has to finalize. Only what he has to comply. He has to comply that 25% is shown for CUF that to be maintained. Otherwise, there is also a penalty if any gap is there in CUF, and as well as if you are unable to provide this 4 hours supply in peak hours, again there is a penalty that is also mentioned there. So you have to only follow that requirement only. Whatever the technology for BSS or solar PV you can use, it's agnostic. Means it depends on you. Only we have to follow the grid code and other CIG or whatever SLDC, State Load Dispatch Center. We have to follow. और with grid connectivity ISTS CTU भी हो सकता है and STU also. We bidder और जो भी okay. ESS of at least 0.5 megawatt oblique 2 MWH capacity for 1 megawatt project capacity shall mandatorily be installed as part of the project. This is minimum, this capacity is required basically. ESS can be from third party also. You can go with third party also. Like you are installing only solar plant, but you are asking other to be you for this 4 hours. I need this 1,000 megawatt. That also you can purchase, but powered from the solar power only. In this tender, because it is solar power, solar ESS, so it should be powered from solar power only. There should not be hybrid. Solar should not be there. And minimum quantum of contractual capacity 50 megawatt for ISTS and maximum quantum of 1,000 megawatt at in multiples of 10 megawatt. Same in other bidding also it happens. Any group company can participate. These are the financial terms basically. Multiple delivery points with ESS can be co-located. For example, 500 megawatt to 1000 MWH and 500 megawatt 2000 MWH. We can do this combination also like that, or other combinations 500 4000 megawatt and 500 without ESS also we can do. At least wherever we are installing the BSS, our solar plant should be there. It should not be only standalone time. Excess capacity can be installed, but SECI will allow only contracted. Excess energy you can sell. Not only this is not for this is this one for this 2000 megawatt. It is applicable basically. Delivery point can be changed up to the deadline of financial closure. Schedule commissioning date of the proposed new delivery point is on or before. Or it is another thing. Okay, for this project it was applicable. Basically. Connectivity we have to apply. If connectivity is changing, you are going with other. So it has to be informed to SECI, and after approval within 7 days, the developer has to apply for grid connectivity. Should on or before the earlier one. Okay? No extension for timeline to be allowed if SPD failed to apply for connectivity in given time frame. Standard for BESS, which we are following up. Basically, that's my inverter UPS, whatever we are following. Indian, whatever the IAS, that is only for UPS, for inverter, or battery. These are the international standard. IEC 62897, safety requirement of stationary energy storage system, lithium batteries. Another one is 62932. This is a safety requirement of flow battery system for stationary application. And 9540 UL standard for energy storage system and equipment. Means right now India is following this international standard only for BSS because we don't have all these parts. We have only for UPS and inverter. These are the safety standards. These are in the RFS document. It is given. All these standards we need to follow. Maximum all international follow for the BSS safety standards. These are the power conditioning unit standard for BSS. These are also international standards. So IS is not still prepared for BSS specifically. This is the global Indian players BYD and CATL. They are the major player basically in battery. Tesla is also there. LG, JW also collaborating with LG, Samsung, Fluence Energy, Nextra, Panasonic, Hitachi, Siemens. Okay. India, these are Excite Battery, Amara Raja, Swastika, Hero Future Energy, so they are own plant. Exicom Tele System. Okay. Okay, now it is finished. It's the time of quiz first. Then we will go with the Q&A session. So, Rayasri, you can put the question sheet.
Yeah, I'm doing that.
In chat box, put the question. Please attend. Is this time you will not come to know the score. We will tell you the answer. We can do the polls also. A poll is there. Let me check. Poly, third party. Okay, you attend all these questions, then we will say the answer. You will, if it is okay with you, then tell how questions are correct. All received the questions?
Yes, sir. I located in the chat.
Only 3
Okay,
questions
you
we
attend
have
it?
received.
Hello,
Okay, 10
is
questions is
there
there.
all the question are visible?
Yes, it is visible.
10 questions are there, so all are visible, I believe.
No, 3 questions are visible till now to me.
Okay,
Yeah,
I'm putting.
in chat.
3 questions.
Yeah, 3 questions.
So you see, why you are not giving that seat link that we can submit our answer in that?
Google form.
हाँ सर. Yes sir.
Yes, sir. Google form is better.
नहीं
You can just
ये थोड़ा सा क्या है, नया क्वेश्चन है, ये भी कर लो ना. क्या दिक्कत हो रही है, वो भी डाल देता हूँ गूगल फॉर्म.
ठीक है. ओके.
sure,
इसमें
sure.
इसमें क्या इसमें टाइपिंग आंसर ये टाइप करके
नहीं
लिखो
नहीं
क्या फर्स्ट आंसर इज
हाँ, आप तो ABCD लिखते जाओ ना, 10 का ABCD लिखते जाओ बस पेन से। फिर हम
ओके।
इधर से बताएंगे, उसमें टिक करते जाने का, भाई हाँ ये सही है या गलत है। तो 10 में से कितने आपके सही आए आप पता लग जाएगा। ईमानदारी तो रखनी पड़ेगी ना।
हाँ सर, हाँ सर।
उसमें नहीं होता, उसमें तो फिर ये क्या है कि वो जो आप गलत है तो गलत ही है, इसमें तो थोड़ा बहुत वो भी कर सकते हो आप। I have put link also. क्या 3 ही क्वेश्चन है या प्रेस भी? अच्छा, अदर क्वेश्चन नहीं डाले क्या? डाल दिए। ये आंसर बता दो, आंसर। Rajashri, only three question is given. Where is
Okay,
others?
but I think your link is visible to all. So I'll be requesting you to all to please check the link.
अरे तो वो ABC तो बता दो, आंसर बता दो कि वो 3 के तो।
Yes, sir.
Why only 3 questions?
Vishwanathan, can
हाँ
you
जी,
go on mute?
हाँ जी,
Can you go on mute?
ओके।
Yeah, it is voice are coming. That's why. So, hi everyone. I'm going to tell you the answer.
Yes, yes,
So,
please.
Yes, please.
yeah. So, number one answer will be B, that is LFP battery. Okay. Number two answer will be C, 60 to 70%. Number three answer will be C, 15 years. Number four answer will be D, that is all of the
नहीं
above.
फोर्थ क्वेश्चन डाला था क्या आपने?
Yeah, yeah. So your link is there.
I
From
think
there, I think
we
everyone is visible. That link.
नहीं नहीं, लिंक आई एम नॉट टेलिंग। जो क्वेश्चन आपने अभी ड्रॉ, वो लिंक वाले वो क्वेश्चन अलग है, डोंट मिक्स इट।
मैम लिंक में दूसरा क्वेश्चन है।
लिंक जो डाला है ना, वो अपना पिछले वाले वेबिनार का था। मैंने बोला था ना आपको, इस बार अपन ने क्वेश्चन बना के केवल या तो पोल कुछ करेंगे या कुछ ऐसा करेंगे, तो वो क्वेश्चन अलग है, डोंट मिक्स दैट वन, ठीक है ना। वो लिंक तो ऐसे दे दिया। आपने सारे 10 क्वेश्चन क्यों डाल दिए क्या अभी? कॉपी करके डाल दो ना
मेरे
इसमें।
इनको हो नहीं रहा है।
Actually, sir, we answered on the linked question only.
हाँ, तो
In chat,
उसका आंसर बता दीजिए। जो नए लोग हैं वो बता सकते हैं, कोई दिक्कत नहीं, नो इश्यू।
yeah, in chat box we only got 3 questions, sir.
हाँ, वो पता नहीं कैसा है, 3 क्वेश्चन जो सारे आने चाहिए।
अच्छा, ये भवानी सर, ये सेकंड क्वेश्चन जो था नॉर्मल क्वेश्चन, व्हाट इज द अप्रोक्सीमेट परसेंटेज कॉस्ट कंट्रीब्यूशन ऑफ एलएफपी बैटरीज इन द टोटल बीएसएस कॉस्ट? इसका आंसर 60 से 70% होगा या 70 to 80% होगा?
नहीं नहीं, 67-70 से बिलो आएगा। 65-70, 67-70।
अच्छा अच्छा, 60 to 70, ओके ओके।
70 से वो नहीं होता।
ओके ओके, ठीक है। And what is the typically lifespan of a BSS before requiring replacement? इसका आंसर 10 years आएगा ना, मिनिमम 10 years आएगा रिप्लेसमेंट का।
10 इयर्स तो वारंटी
15
होती है, रिप्लेसमेंट आपको 15 इयर्स में करनी, बताया था ना
रिप्लेसमेंट का
मैंने।
थर्ड ऑप्शन नहीं है ना सर, ए बी सिर्फ ऑप्शन है। ए में 5 years, 2 और बी में 10 years।
नहीं, थर्ड क्वेश्चन का आंसर इज 15 इयर्स। पूछ भी रहा था क्या, मतलब क्या
हाँ,
था
वो
आंसर थर्ड
ऑप्शन वो
क्वेश्चन? लेट मी सी थर्ड क्वेश्चन व्हिच इज।
भवानी साहब एक काम
हाँ
कर सकते हैं क्या? बिकॉज
हाँ
आई
जी,
हैव अनदर कॉल एट 8:30 नजदीक हो
ओके
रहा है
ओके
सर मेरे लिए।
ओके
तो व्हाई डोंट
ओके
यू,
सर,
एक और चीज है कि आप रिजल्ट सबको अलग अलग भेज दीजिए ना अपना मेल आईडी में, इट विल बी इजियर।
ठीक है। ठीक है जी, क्वेश्चन का बोल रहे हो क्या आप?
हाँ, ये जो क्वेश्चंस आया था उसका रिजल्ट
हाँ,
आप
सब
हमको
सब
अलग अलग
ओके ओके,
ईमेल आईडी में भेज दीजिए ना सर।
ठीक है। मैं आई विल ये सेल द ईमेल आईडी और पीपीटी भी भेजने का करता हूँ मैं इस बार, ठीक
प्लीज
है।
सर, थैंक यू सर, थैंक यू, थैंक्स,
ओके
थैंक्स वन एंड ऑल, थैंक यू। ओके, बाय
ओके, थैंक यू
बाय।
थैंक
सर वो एक्सेल शीट आप बोले थे कुछ दिखाएंगे सर कैलकुलेशन का?
यू। एक्सेल शीट दिखाता हूँ यार अभी।
सर ऐसे शेयर किया तो बहुत अच्छा रहता है।
क्या चीज, पीपीटी?
नो पीपी नॉट द एक्सेल शीट।
नहीं नहीं, वो तो मैंने कैलकुलेशन की थी, अभी देता हूँ। पहले एक मिनट, मेरे को इसको
ओके,
देखना होगा, मिल जाएगा आपको, कोई दिक्कत नहीं।
बेटर फॉर अस।
नहीं नहीं, श्योर श्योर, आई विल डोंट वरी। ठीक है, बाकी ओवरऑल क्या फीडबैक कैसा रहा? अच्छा।
हाँ सर, यस सर।
Yes, sir, it's great, sir. It's good to know about the BS currently, sir. Everywhere we hear about BS, but we don't know much detail about it, sir.
थैंक यू। श्रीकांत जी, आप कुछ बोलना चाह रहे हैं क्या?
सर एक्चुअली में थोड़ा इन ट्रांजिट हूँ इसलिए थोड़ा प्रॉब्लम आ रहा है, बाकी कोई नहीं, बट इट वाज अ ग्रेट लर्निंग आपकी तरफ से। आज बीएसएस का और डिटेल्स का सीखने को मिले, मोर डिटेल्स देन द लास्ट सेमिनार,
नहीं,
मच
मैं
मोर प्रैक्टिकल
what
यूसेज।
what I'm doing, I am sharing PPT also this time, so that people can
ओके, ग्रेट
understand better. Okay,
ग्रेट सर,
I will share over the email ID to all
यस
participants who have 15 December, 19 December, then 29 December. This
यस
is our fourth one, 5th January. Okay, so
यस,
Okay.
uh,
थैंक यू
I
वेरी
will
मच।
Sir, this is recorded session. Yeah, only right now working.
No, recording. You will get
Yeah.
recording also. You will get, and also PPT also. I am going to share. Don't worry.
That's sir. Actually,
Because
sir,
this is our last webinar. I am changing another subject because fourth. It's fourth one. So
yes,
still there are a lot of things. Okay, so it need more time to final conclusion, basically.
right.
Okay.
That means, sir, initially 1 hour I just skipped the due to traveling.
No,
Okay, so
I will
I'll
share
cover
the
sir.
I will share the recording also. We have the recording of our other previous session also. That also we can share. No issue. You can check our
Great, sir.
this our YouTube link.
Yeah, it's great, sir. We
Yeah,
enjoy
Presley,
very
you
much.
share the YouTube link, okay, of our both last session, 15 December and 19 December also, because something new also we discussed there. Basically. Okay, in every
Okay.
session something new are there, so you just see all the session.
Okay.
भवानी सर, वो LFCO का सेट जो भी इनकम्प्लीट था, थोड़ा उसमें कंफ्यूजिंग था, तो वो क्या नेक्स्ट क्वेश्चन में क्लियर करेंगे कैसे वो कैलकुलेट करके?
अरे अभी अभी कर देते हैं ना, टेंशन क्यों ले रहे हो आप? हैं?
नहीं सर, आप है तो टेंशन क्या?
चलो, नहीं कर देते हैं, अभी आपको करना अभी कर देते हैं या 1 2 का करें, कैसे करें?
नहीं अभी कर दीजिए, सारे लोग कुछ समझ जाएंगे भी तो।
So we
ठीक है।
also want that, no?
यस यस।
ठीक कर लेते हैं ना, कोई इश्यू नहीं है।
भवानी सर, मैंने एक व्हाट्सएप पे आपको एक इमेज सेंड किया है, वो स्टैंड अलोन BSS का है वो सीट। ओके, उसका एक बार देख लो ना प्लीज कि उसमें कैसे कंपनी ने वो कैलकुलेट किया है, वो आपको पर लैक्स पर मेगावाट पर ईयर, मतलब कितने मेगावाट में कितने लैक्स को उन्होंने कोट किया है सेकी के लिए
अच्छा,
या जीवनल के लिए।
हाँ, ओके देख लेता हूँ ना।
हम्म।
एक सेकेंड, क्लियर कर देते हैं।
श्री आप ये वाला ये जो PPT है ना, आप मेरे व्हाट्सएप पे सेंड कर देना प्लीज।
Please share that Excel sheet also.
Which Excel sheet?
That calculation sheets.
बिल्कुल भेज देते ना।
Okay.
आपको क्या था वो कैलकुलेशन का, क्या था मैटर अपना?
हाँ सर, कैलकुलेशंस का मैटर था, जो कैपिटल कॉस्ट आ रही थी ना, कैपेक्स का, ओपेक्स का,
लेवलाइज
ओके, कितनी कॉस्टिंग आ रही।
लेवलाइज जो cost था उसका बोल
हाँ,
रहे थे ना।
लेवलाइज्ड कॉस्ट वाला। हाँ, लेवलाइज्ड LFC हुई।
ओके। कर लेंगे अपन। ठीक है, ये किसका? अच्छा, 8/10 का सीट को किया है क्या? अच्छा, वेरी गुड। लोकेंद्र सिंह से, वेरी गुड। सुरेश बाबू, अरे भाई सुरेश बाबू, आपके तो 10 में से 10 आना चाहिए था।
किया था बट अभी 2 चीज का हो गया, वो मिसमैच में वो क्लिक किया था।
अच्छा, किशोर 9/10, ग्रेट। कुमार राजीव 8/10, वेरी गुड। चलो, ओवरऑल ठीक है। तो इस बार क्या कर रहा हूँ मैं, आई विल शेयर द PPT आल्सो एंड आई विल शेयर दैट सीट आल्सो, कैलकुलेशन सीट फॉर दिस लोकलाइज कॉस्ट ऑफ लेवलाइज कॉस्ट ऑफ इलेक्ट्रिसिटी, एंड इसकी जो आपकी वो रहेगी वो मिल जाएगी आपको, कोई इशू नहीं है। ठीक है, no issue। चलो, ओके फिर। एनी क्वेश्चन?
वो मेरा व्हाट्सएप वाला देख लो ना सर एक बार प्लीज।
अभी खोलूँ क्या? बाद में करता हूँ ना।
अच्छा, बाद में करेंगे। ठीक है।
यार हेमराज जी, अभी तो थोड़ा आराम कर लेते यार, संडे यार, आज सुबह से तैयारी करना था।
Sir, can
अरे
you
नहीं,
slide number